welcome to the channel. This video is going to be about again another video on credit risk, where we are going to build a model which will predict the possibility or probability of default, probability of someone being defaulter. Okay, so by now I hope you understand what default means, etc. If you don't know, I'm leaving a link into the description section. You can just give it a watch and you will understand what probability of default is. Now the point which you should notice is here I'm going to download the data from Kaggle, and this recording is, I would say it's a reality recording rather, I would say. Okay, what does that mean is I'm not first practicing the thing and then doing the recording. I'm going to do it on real time, or in real time rather, I can say. So and I'm going to keep the level of this video is absolutely manual, so that's something you would find me using very less less of the automated things. Okay, I'll be exploring the things manually, so that's where I recommend, if you are the beginner, then this is going to be best for you. You will be understanding the things in detail over here. Okay, so let's just start with the video. Okay, so here this is the button. I'm going to leave this link into the description section. Just click that, this page will be opened, and click on this data will be downloaded. When you download this, it is going to be in compressed zip format, and you can open this. What I did is I opened it and I placed it in a separate folder here in tables, and here I have that data available. Now as soon as I had the data available, what I did is I jumped directly to the Jupyter notebook, and over here I have just imported basic libraries, right? Basic libraries which you might be very much familiar with: pandas, numpy, seaborn, and matplotlib. Okay, and after that, here I'm just reading the data. This is the thing which I have already done, and I think it is pretty much a basic thing which you can do very well. Okay, now the next thing I'm going to start with is exploring this data first of all, right? So for to explore that, what I'll do is let's just see what is the shape of this data. So it says these many records and 12 columns. What we see over here is all the columns which this data has. Now let's just see the statistical description of this data. Describe. Okay, over here you see 1 2 3 4 5 6 7 8. Only 8 columns are reflecting. However, if you remember, we just checked that it had 12 columns. Why it is showing only 8? Because out of 12, only 8 are numeric columns, and describe gives you the statistics of the numeric columns, not for the categorical columns or alphabetic columns. Okay, character columns rather, I should say. All right, lot of talks. Now let's just dive into the numbers, or I can say the statistics. Let's have a look at the person's age. What it says is over here the minimum age is 20 years, which is very much practical. If somebody is applying for a loan, he or she is expected to be greater than 18 years old. But you see this 144 years old. Who on this planet at this point of time is 144 years old and applying for a loan? What exactly that he or she is going to do with the loan? So certainly this is the data error which I would be deleting from my data. Now you let me know into the comment section what exactly that you feel you should be doing and what you are trying. All right, now the next one which I am going to look at is person income. So this is something which we will see further. We will try to plot it and then we will see its distribution. I'm not going to make any decision on this column at this point of time. Next, if I see person employment length, see who is the person who is employed for 123 years. I mean, in present time, the retirement is 65 somewhere. At least in India it is 60 to 65. Okay, so who on this planet is working for 123 years? I don't think so, right? So again, this one is something which looks unpractical to me, which I would be deleting. Again, you let me know what exactly that you are going to do while you are building the model and how it performs. Now In the loan amount, that looks that's something, again, we will see the distribution later on. Interest rate is also something we will see later on. Status is nothing but it is simply telling you whether it's a defaulter or non-defaulter. Loan percent income, this is nothing but debt to income ratio, right? And a CB, person credit history length, how long the credit history has been for this person. That's what it is saying over here. So the maximum is 30 years, so this person is having 30 years long credit history. All right, so what we found I mean not relevant is this and this. So I'm just going to go ahead and delete these two things. Okay, so before I do any further modifications, what I would do is I would just make a copy of this data so that originality of the data is remains, right? So let's just say credit risk copy equals to credit risk dot copy. I don't want to spoil the originality of the data, so that's where I'm just keeping it. Now the next thing which we are going to do is we are going to delete this part. Okay, so I'm going to say copy risk credit risk, or let me just make it smaller. Credit risk CR risk, I'm going to say as credit risk, and age removed equals to credit risk where person age. So what I will do is, in my thought, what I'm going to do is anyone who is greater than 90 years old, I'm going to delete that. So let's analyze that first. So credit risk dot pivot table, I'll do a quick analysis. Pivot table index, and over here I'm going to use person age. Values we can put anything. Person income, let's say you can put any column. Okay, is count. Let's just see what is it that you are getting. All right, so this is what you are getting over here. Or here I'm going to say not person income, but I'll put another column. Let's just say columns I'm going to put over here, and into this I will put this one, loan percent income dot reset index and dot sort values by person age, ascending equals to false, ascending equals to false. All right, now I'm confused whether it should be single equals to or double equals to. It should be single equals to. All right. I just get confused sometime. Okay, all right, so why it is what it is. Okay, loan percent income, I should not use loan percent income, rather I should use loan status, whether it's a defaulter or non-defaulter. That was an incorrect thing which I did. Now let's just see on this part. So the person who is greater than 70 years old, let's see, the person who is greater than 70 years old, the chances of them are being the number of those type of customers are very less, and the probability of default, number of default is almost null. Okay, so what I'm going to do is, in my data I'm going to take a call while building this model, that whoever is greater than 70 years old, I'm going to delete that data. What do you think? Is that a good idea? I think that's a call which I would require to take. In my model, I'm not going to consider any data point where the age is greater than 70 years. I would not like to provide any loan on that. Okay, that's simple, right? Whenever I'm making any decision, I would not like to provide any loan. I'm trying to reduce the possibility of risk. So simply I'll delete all those persons, all those records where the age is greater than 70. Okay, so that's it. I'm just going to do this. Okay, now you let me know what exactly that you did with your data, and then we will see. Okay, here I'm going to say less than 70 years. All right, and then let's just see, this is removed. Now let's just check the shape of this. Now we have 32,561. Initially, how many we had? If I check out the shape of credit risk dot shape, I had 81, 32,581. Now I'm left with 61, means 20 records are deleted. Okay, now this is done. Next thing which I'm going to do is I'm going to focus on length of employment, right? Let's just have a look on this length of employment. So let's just click this again. I'm going to create another pivot on that pivot table, and inside that I'm going to say index equals to, you might find this video a little lengthy. If you're seeing that it is too slow, you can feel free to watch this at 1.5 x speed, or maybe on 2x speed. That's going to be absolutely fine. Okay, over here, next thing which I am going to do is person employment length. Let's just see what is the thing that we have, and in columns again I'm going to consider the status, loan status, whether it was default or not non-default. Values, let's just consider person income again, person income over here, and then aggregated function I would use count, and then reset index, and then sort values by employment length, and that is descending, sorry, ascending equals to false. That's what I need to say. All right, let's just hit run and let's just see what's gonna happen. All right, so 123 is unpractical. We need to remove that. That's for sure. There are two records for that. What is the minimum is that minimum length of employment that we have, that is 0 years, and with that we have this many records. The number of records are quite significant. It says 0 years they have been employed. All right, I'll keep this for now. I'll not delete this. I will keep that for bivariate analysis. Okay, I'm just all right, I had paused the video because I didn't want to entertain you with the dog's noise. That's why I just paused the video. Now coming back to the point over here, what we see is 123. There are two records with this. So what is the practical length of employment? So let's consider at 18 years, anyone is allowed to start their career at 18 years, right? And by 65 they generally get the retirement. So difference between 18 years and 65 year is approximately 47, isn't it? 18 or to 20 and 40 60 and then again 5, so 47 years. So anything where the employment length is greater than 47 years, I will delete that. Okay, I will be deleting that record. So let me just take that call and let me proceed with that. So for that, what I'm going to do is, here I'm going to say person emp removed equals to this data actually, and then over here again this one, then comes this employment length. If that is greater than 47 years, then I'm going to delete that record. Okay, you with me? Dot shape, let's just see. Oops, why is it saying just two records? No, sorry, here I need to keep those records. I'm not deleting it. Actually, I'm saying ki wherever the age is less than 47 years, just keep them only. All right, now here we got, here is what we got. Okay, so here it says 31,665. So quite significant number of records are deleted, isn't it? Yeah, that looks like quite significant number of records are deleted out of it. Why is that so? There were not much number of records. Okay, let me say less than or equals to 37 47,000, sorry, 47 years. All right, this is this is it. So I'll just go ahead with this. Okay, so this is done. Now next thing which I'm going to look into is, let me just again have a describe thing. Describe over here what we see. Now this looks pretty relevant, right? Person's age is, okay, let me come back over here and here also say less than or equals to 70 years. Okay, this 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 61 increased to 68, and then here it is coming 31,671. This is all right. Now this also looks pretty well, 31,000. Okay, now this is good. Here what it say is maximum age is 70 years, minimum age is 20 years, employment length is 38 years, which is good. Now the next thing which we are seeing is minimum is 0 years, minimum length is 0 years. Now pretty much in shape. Now let's just check about the null values. Okay, let's just have a look at null value. The dot is null dot sum. Let's just see. Okay, all right, so loan interest rate seem to have huge number of missing values, right? So that's something which we would require to do the treatment of. Okay, so now on rate of interest, let's have a look on the statistical descriptive statistics. What we see is loan interest rate. Where is loan interest rate? Over here. So it says mean is 11%, minimum 5% rate of interest, and average rate of interest is 11%. What is median? Median is 10%. What it means is, means half of the data is having rate of interest as 10%. Okay, and see the maximum is 23% and minimum is 5%. So if you see, median and mean are very close to each other, right? So I think we can go ahead with either of these two. Either we can fill the missing values with median rate of interest or the mean average rate of interest. So I will choose to do this. I will do this one. Okay, so let's just try to fill the missing values into it. Again, I'm going to create a copy of this data. Dot copy, and I'm going to put it in credit risk data. Okay, this is what I'm going to do. Sorry, dot shape, and let's just see, this is good. Now let's just do one thing, this, and inside this I'm going to do, all right, so let's just try to fill the missing dot fill na, and inside this we want to fill column. Which column? This one. Okay, this column we want to fill the missing with, and the value which we want to fill the missing is this, and inside this one, and this, then I can say median. Oops, I just hit the tab key. Now it will take its own time to complete, to do the autocomplete. I'm so sorry for this. This is something which is a time consuming part. Now this is done. Let's just see if this gives an error or what. Okay, seems like it worked. Now let me try it again and check out the missing values is null dot sum. Okay, does this mean I need to say in place equals to true? Is it in place equals to true? Yeah, that's gone, right? The missing value is gone. Super. Now that is also done. After that, what else that we should be doing? Now let's again just see the describe of this data. Dot describe. So here I replace the missing values with median. Now if you want to replace that with mean, you can go ahead and do that, and if you want to replace that with backward or forward, that you can also do, right? I have a separate video on that, you can just check that out. Okay, now that looks pretty well. Okay, now let's just have a look at the number of values that we have. Okay, number of records that we have, so that we could determine whether the data is balanced enough or not. Okay, so how can we determine that? That's basis on the loan status. So what I'm going to say is group by loan status and dot count, and I can pick any column, let's say person age. Okay, so this still looks kind of imbalanced, right? If you will see this, then we can let's just do a quick calculation. This divided by this plus this. So approximately 21% of the records are positive, and so let's say 20% of the records are positive, rest 80% is negative. The balancing will be when you have 50-50, right? If you have 50% of the data as positive, 50% as negative, or if you have at least 60-40, then I will consider it, at least in my thought, I will consider that as balanced data. So remember, take a note, we would require to do the balancing of the data also, but not at this point of time, we will do it in some time. Okay, first let's just, now we are done with missing values treatment and some unpractical data removals, right? Next thing, let's just have a look on the categorical data. Let's have a look at categorical data. Let's just have a look on that. I'm just going to print that data again, this one, and let's just have a look at the head of it. What it shows is there are two categorical columns, this one and this one. Let's take a group by, let's just take it one by one. Cr data dot group by, and inside that let's just see how many categories are there, what all are the categories that we have. I mean, this is the way which I prefer. You can always have a different way of doing the things, that's absolutely fine. Okay, and I'm just going to take this one, and let's just see. So there are four type of loans: mortgage, no, sorry, home ownership, right? Home ownership, there are four category of home ownership. One is mortgage, other own and rent. Now let's just try the same thing. I'm just going to do the same thing for this variable, loan intent. For what purpose the loan, the person is taking the loan, right? Now let's just see, there are how many possibilities, I mean how many reasons for which the particular person is taking loan. That is 3 and 3 6 reasons. So like you can see, this is categorical column. Now to treat this in model, to put it, we require to have it in numeric form. So how do we, okay, there is one more, this loan grade. I don't know the importance of this loan grade, but let me just see. Because let me have a look if it has the definition also. Loan grade, the definition simply says loan grade, it does not talks a lot about it. So if it has some more values, then I would just think of dropping that. lone grade. Let's just see what is the distribution. 1 2 3 4 5 5 6 7. These are just 7. I can still think of keeping them, right? I can think of keeping them, or what we can do is we can think of grouping them. But in my thought, what's going behind in my mind is I should drop that because I don't understand the meaning of it. I don't even understand the meaning of it, so I don't see any point of keeping it. I'll drop it. Okay, I'll just drop it. So let's just say credit risk, credit data. Again, I will create a copy of it. Data copy, and over here I'm going to say this dropped drop. Let me just see the parameters of it. Okay, I can simply write the column name. The column name is loan grade. I'm going to drop it. If you want to keep it, you are more than welcome to do that, and let me know the performance of your model. I would also learn from that. Okay, something went wrong. Levels index column. Okay, I index. Why did I write index equals to? I should say in place equals to true. But first let me say this, in place equals to true. Okay, let me remove it from here. Done. Non-type object has head, so it has removed everything, is it? Okay, let me see, where did I just I had created a copy of it, isn't it? Okay, I did something wrong. Okay, let me just see if this still has the data. Okay, this has the data. Now over here there's something wrong. What exactly? Non-type object has head. When I'm removing it, so I should say drop, and inside that I would say loan grade and axis equals to 1, and let me put it, I would say dropped. Okay, let me first create a copy of it. Oh god, I'm taking a lot of time. Copy equals to this dot drop, and inside that I would say loan grade axis equals to 1, and let's see what happens. Why is it saying loan grade not found in the axis? Loan grade, where is that grade thing? I had it here. This now I don't see that. Is that gone? It looks like that is gone. Group by. Okay, so I think that is already dropped, and that is already dropped, so we don't need to worry about it. Okay, CR data, or what we can do is CR data. Is there any CR data? Where did I make a copy of this? CR data here. Here I had made the copy of that. I'm just, now you see how important is it to have a checkpoint in your data. Now it just worked, and let me just see if what is the shape of it. Now this is done. This looks pretty much well, pretty good. Okay, so after dropping that, I've created a copy. So let's just not go by the name at this point of time, and let's just be with this naming convention. Okay, now this has only 11 records, means loan grading is gone. Okay, now the next thing which I'm going to do is I'm going to they do the treatment for these categorical columns. Now that we are done with treating the numeric columns where we had missing value and some outliers, we are done with treating those all. Like we said previously, that in this one we are going to take care of the categorical features, right? So let's just have a look in this data frame how many categorical features are there. This is the one, then this one, two, and this one, three. So there are three categorical features. Now we will do the treatment of these categorical features, how we need to make it usable by the model. So the challenge is model will not work on this categorical columns. We need to convert it into the numeric, and for that there is one technique which is called one hot encoding. Now if you want to understand what one hot encoding is in detail, the link is given in the description section, just check that out. Coming back, so we will do the one hot encoding for this data, for these categorical features. But before we proceed further, if you notice over here, this index is starting from 1, while in Python usually the index starts with 0. So now if we have this starting with 1, and if we create another data frame which is starting with 0, and if we try to merge both of these together, that might create some problem. I mean, definitely that will create the problem. Okay, so first of all we need to fix this, which we missed to notice in the previous video. So let's just check it out. Where is it starting from, right? Where is it starting with? So over here it is starting with 0, that is fine. Then the next one here, you see over here this is starting with 1, right? CR data head. So CR data head is starting with this one. This is where the challenge, this is where the problem seem to be. So what we will do is we will just have a look in this, why is that happening. Okay, let me just have a look. Person empowered. Okay, so over here the data, there are two filters which we have done over here, right? So let's just see if this is, how is this looking like. So this is starting with 0, but in between, because we filtered out the age, where the age was great, we filtered out those, I mean we removed those records where the age was greater than 70 years. So certainly when you filter out the data, that goes along with the index number. So what we need to do is we need to reset the index. Over here you might not find it visible. Let's check out in this one, right? Over here, let me just have a look over here. Dot head. All right, so over here you see it is starting with 1. So in both of these two, when we are removing some rows, we need to make sure that it is taken care of very properly. Okay, now let me just take care, I mean do the treatment over here first. So what I'll do is, oops, sorry, this one and this one. Okay, first let me just make this correct. Okay, then over here I need to say reset index, and into this I need to put two condition, drop true and in place equals to true. All right, and then after that let me just see how does that looks like. All right, this seems to be corrected. You see it is starting with 0. Now over here I will just do a cross check again. If it is all fine, seems to be correct over here. Let me just delete this now. This is not needed. Okay, this is done. Same thing we are going to do for this data frame as well. We will do the same thing for this one as well. Okay, now let me just look into this. Why I'm checking the head of this one? I should be checking the head of this one, right? Okay, now let me just say reset index, and into this two parameters, drop equals to true and in place equals to true, in place equals to true. And then let's just have a look on the head. Okay, it also seems to be correct, right? So this is done. This one this is also treated, and this one is also treated. Now I think if I run it again over here I should see it starting with 0, right? Because other than that nowhere else I have applied any filter. So what I'm going to do is I'm going to run all of them, all of the cells once again. Okay, so for that you have this option which is called restart and run all. Let me do this and let's just see how it goes. All right, let's just see what happens. Okay, this is executed. Bingo, looks everything fine. Now you can see over here it is starting with 0. Perfect, our data frame is good in shape. Now let's just start let's just start treating these all things. Okay, so there are a couple of things which we need to do. First of all, this treatment, let's just try to look in the categorical features. Okay, so first of all, let's just see how many categories that we have in this data. Okay, again I would say, first of all, so many times I'm saying this, so before we proceed further, what I am thinking is I should make a copy of this again. Okay, cat treatment dot, or let's just that be copy dot copy, and over here I'm going to say cr data categorical treated. Okay, this is what I'm going to say over here to this data, and over here I'm going to have a view on this categorical column, how many categories that we have in this particular column, and then let's just say count, and any one of the feature can be filtered out. For example, let's say person's age, so that we see only that categories. All that I wanted to see is this one, right? How many categories are there? That is what you can also use unique, etc. So mortgage, other, so there are 4 categories. I think we are it is good that we go ahead and do this treatment. Okay, now in this one, what is the, how many values are there? I just want to see how many unique values are there. Into that we have 6 unique values. That is still okay. So why I'm checking this is, if we have too many categorical categories, then we need to think of how do we treat that differently. Now in this one, how many categories are there? This seems to have only 2, yes and no. Okay, so there are two things which we are going to do this. For this and this one we will do one hot encoding, and for this one we will simply replace with, will simply make it a binary, means wherever it is no we are going to say as 0, and wherever it is yes we are going to say that as y. All right, let's just start with it very quickly. So I'm going to create, so there is one method which is called pd.getDummies. Okay, and inside that, this the column which you want to convert, right? So this is the one which I want to convert. All right, let's just see how it looks. Now you can see we into this column we had 4 category of loan: mortgage, other, own, and rent. And over here in one column we are seeing them all. Now for each of those categories a separate column has been created, and wherever that particular record, that particular row was belonging to a particular type, for example you see this row number 1, okay, that is for mortgage. So for that mortgage you would see over here it is true. So similarly it will it would have for all of these loan types. Now over here what I'm going to do is, this is looking as true false. Now we need to have it either 0 or 1. So here is the thing which is called as type, and into this you just put int, that is converted into 0 or 1. Now I'm going to store this data into a variable or maybe a data frame which I would name as person home ownership. Okay, and you can just have a look on this and let's just see. So this is looking perfectly fine. Now the same thing we are going to repeat for another column, and that column is loan intent. What was the purpose for which the loan was taken? Okay, now let's just see. This is also done, and now let me just store this in loan intent. This is also done. Let's just see head. Perfect. Next one which comes is converting this from n and y to y, or I mean, wherever it is y we need to make that 1, and wherever it is n we need to make that as 0, right? So that's what the conversion we are going to do, right? So let me just create, so this conversion we will keep in this same data. It is nothing, just creating a separate variable, that is it. So here I'm going to say binary, that is that's the naming convention I'm going to use. Okay, now let me just, there is one function which is called np.where, which is nothing. If you have used if else in excel, you would you require to do exactly the same thing. In if else in excel, when we do, what we do is we first refer to the particular cell, and then we write the logic. So here I'm going to say if this particular variable contains the value y, right, then put 1, else put 0, right? That's exactly what we need to see. And let's just see that. So these two will remain as it is, because for these two I have created separate data frame, right? And over here you see another column has been added which has value 0 for n and 1 for y. Okay, now into out of this we will drop this particular column. Okay, now what I'll do is I will just, or let it be for now, to let it be, let's just let that be. Now after this conversion, what I need to do is, from this data frame I need to drop all these three columns. Okay, I need to drop all these three columns, and then I need to do the scaling of this data. What does that mean? If you have a look at the age, this is showing 21, but if you look at the value in income, it is saying 9600. So if you supply this data into model, what will happen is model will understand that this is having more value than this, right? This is more important than this, while in reality both of these two have its own significance, right? It is, there's no relation that this is greater than this or etc. Okay, by number if you see, of course it is greater than this, but you are aware that both of these two have its own significance. So that's what we need to standardize in the data, so that model do not get diverted, right? Model is not distracted from the reality. Okay, so that's what we need to do. So now what standardization is, standardization means for a particular column or for a particular feature the mean is 0 and standard deviation is 1. If that is something which you have achieved, then your data is standardized. So that's what we are going to do over here. Now again, for this also I have a separate video created, link is given in the description section, just check that out if you want to understand that in detail. Now after that I'm going to create another data frame in which on which I would be doing the scaling. So to do the scaling, what we should avoid is categorical column, for sure we are not going to consider. Now after that we should also avoid putting the binary columns into that. So for example, you see this column, this is to, for sure we are going to drop. This column is also something which we would require to drop, because if you do the standardization of this, it will lose its own meaning, right? Where it has its own meaning, this is nothing but just a flagging thing, right? So we should not do the scaling for this. All right, so let's just create a data frame where we need to keep only those columns which requires the standardization, right? So let's say create data to scale. I'm creating another data frame, and into that what I will do is I will take this data frame and I would say drop, and into this I'm going to provide the list of all those columns which I don't require to scale. So this is categorical column, any which way I needed to drop it, right? So I am just dropping this. If in case of any question, any doubt, please feel free to put that into the comment section. I'll be more than happy to answer that. Loan status is also something I don't need to do the standardization on. And then this column for sure we want to drop, we don't want to continue building our model on this. And this one currently we are dropping, but later on we will just bring that again. Okay, and here I'm going to say axis equals to 1. Now this is done, and let's just have a look on the head. All right, so here we got the data which we were looking for. 1, 2, 3, 4, 5, 6, 7. 7 columns we have, right? Now on this we can do the scaling. So to do the scaling, what we need to do is, there is a formula which is, let's consider this feature is x. So the formula says x minus mean of x divided by, so this will be in bracket, divided by standard deviation std of x. So this is the formula. Now if you're looking at this and if you're thinking that this is something which we are going to do one by one, no, that's not the case. We have a module in scikit-learn that is called standard scaler. I have already imported that at the top over here. You see, this is something which I have already imported, that is part of sklearn pre-processing module. Okay, so the same thing which we are going to use over here. So I'll create an instance which is called scaler. You can name it whatever you want, and standard scaler. Now after that, what we need to do is, I am going to say scaled data, or let me just first do the scaling dot fit transform. There is this function which we need to call, and into this I need to put this data. All right, so this is done, the scaling is done, and I'm going to put this in what we say, scaled data. Bravo, it is done. Now let's just check the shape of this data. So it has 31,671 rows and 7 columns, right? So now again, we currently it is an ND array. If you would see, this is says it's an array. We need to convert this back into the form of data data frame. Okay, so that's what I'm going to do. I would create another data frame which I would say scaled df, and into this I'm going to say pd dot data frame, and inside that scaled data I'm going to put in, and columns. Into this I will provide the list of all these columns. Okay, for that a simplest way will be to take the list of the columns dot columns. Here is what we got, and list. Okay, this is the complete list. I can copy paste this list. Done. All right, let's just see if this works. If it does not work, then I will do something. Okay, this scaling is done. Now to validate this, what I will do is I will just try to take a mean of this one, any of the column, right? Let's just take personal income. Okay, I would say np dot mean, not mean, it is mean. Okay, dot scaled df dot personal income, scaled df dot personal income. Okay, it is showing. Okay, let me round it. This is not 1 actually. It looks like to be 1 but not 1. You see, the mean is 0. Now just check the standard deviation, that is 1. So this is how it has been converted. Now we can say that our data is scaled, and let's just say mean. You see, everything has mean as 0 and standard deviation as 1. You see, and over here I'm going to say standard deviation. So I think you have understood that the data scaling is done. Now what we need to do is, you remember we had removed some of the columns, right? Over here we did the we created the dummy values for these categorical columns, and this one is also something which we had removed. So there are these are something which we need to bring that back again in the data. Okay, now let's just do that one by one. First of all, I will concatenate both of these two, and this is something which I will bring from this data frame again. And then there is one more column which we had a drop, that was the loan status. Let's just do this one by one. Okay, so here I'm going to say pd.concat, and over here I'm going to provide the list of all the data frames. This is scaled df, comma, then I had this one, and after that I had loan intent, comma, loan intent. This is the data frame, and this concatenation I want to do across across columns. Okay, now I can say scaled data combined. Okay, this is what. Before this, let me just check the shape of this data frame so that we would have at least clarity. You see how many times I'm checking the validation, I'm doing the validation of the data frame so that we don't miss anything at any point. Okay, now over here I would again check the shape. All right, this looks perfectly fine. So number of rows are same. Into this we had 7 and now 10 variables more has been added, because over here you would see the each of these had approximately. Okay, there is one more thing which I need to do over here. That thing is, if you would see over here, this one dot head, so it has all the four room ownership or house ownership status, right? So but when we are doing this one hot encoding, we usually drop one out of all the categories, and by default if we get 0 in all of the available columns, that says that this particular record belongs to the category other than the three which are available over here. So that we need to do the treatment, and for that there is one parameter which is called one argument which is called drop first, and that I need to say true, and same thing I need to define over here also. Done. And over here also. Now if you see this one, it is all 0. That means this particular loan application depends to the person who has their house mortgages. So you see index number 1, and that belongs to mortgage. So the same thing which we needed to do for this one also. So that is also done. Now the number of columns will reduce. Let me run it all again. You see now we are at 15. 2 columns are gone. This is done. Now after this we need to bring the binary data inside this. Okay, so where we had this, we had done the drop, this one. You see this is the column which we need to bring in, right? And that we can bring from this data frame directly. And from here we need to bring this data frame. I first need to ensure that whether that is existing into it or not, and I'll name this originally. I'll just remove the binary, that is not needed anymore. Okay, you can name whatever you want, but for now though this is what I'm going to do. Does it have that? Yes, it has that. Okay, so now I'm just going to remove this. This will come in, this will come inside it, and let's just see head of it. Perfect, we got that. Next one, loan status. We require to bring the loan status also, right? So the same line of code I will copy, and over here I'm going to say loan status, and here also loan status. Yes, that is also over here. Perfect, we are done with scaling our data and treating the categorical columns, right? Now the next thing which we need to let me just save this data, save this process. I hope it was easy to understand and you have got all the concepts. In case of any doubt, put that into the comment section. I know video is becoming a little longer, so if you want you can watch this video at the speed of 1.5x, right? But keep in mind this is something which I'm creating from the absolute beginner perspective, right? So that's why I need to take the things one by one. All right, now after this what we need to do is we need to check out the distribution of our target column, right? How many rows are, what is the distribution of this, how many are defaulters and how many are non-defaulters. This is the target column. Okay, now let me just try on this. So what we are going to see is scaled data combined, and inside this I'm going to say group by, and inside this I'll use the column loan status done, and let's just take the count, and over here any of the column can be taken. So you see this is kind of, it is approximately 20% and this is 80%. Let's just find the percentage of it. This divided by this plus this. So 21% is positive, rest is negative. Okay, so this is kind of something which we can put, we can easily put into the category of imbalanced data. So how do we take care of this? So for this there are multiple techniques to balance the data. So we say usually I refer to the data where the distribution is 50-50 or at least 60-40, right? If that kind of distribution we have, I would say that it is a balanced data. Now the data is not balanced, so what we need to do is we need to do the balancing. So for balancing there are multiple techniques. So ensemble technique is there, smooth technique is there, undersampling, oversampling, k-fold cross validation, all these techniques are there. I have created separate videos for each of these. Please give it a watch and let me know in case of any doubt. Over here what I'm going to use is smooth balancing technique. Okay, I will use this smooth technique, and I will do the I'll do the balancing of this data. So smooth technique is nothing but is just synthetic data creation of the minority class, right? That's what it is, right? It is simply creates the synthetic data for the minority class. So let me just show you how. That's something which I had already done in the previous videos. What I'll do is I'll try to take a reference from there itself directly. Balancing, let me just see. I have the other video, you can take a reference from that, and the link is given in the description section. I highly encourage you go ahead and check that out. Now what I'm going to do is I'm going to have a look into this oversampling using sampling majority. This is the smooth. Okay, no, this is undersampling the majority class. This is smooth, right? Say smooth stands for synthetic minority oversampling technique. Synthetic minority oversampling technique. So this is exactly what I'm going to use over here, right? So you see this is simply, you can bring from this is the library you must have. If you don't have it, you just run this method, right? Which is I mean, just run this line, you will have this installed, and then after that you can import it from here. So it is nothing but says from IMB learned I want to bring oversampling, and then smooth is the technique which we need to bring. Then after that what you can do is you can create an instance, and then after creating the instance, what we're gonna do is we need to supply, you see over here we are supplying the data for balancing, but when we are supplying we are keeping the dependent, means the target column we are keeping separate, and features we are keeping separate, right? And then we will do the balancing, and whatever we get over here, that's something we can further supply in our model, and then we can do the model training. Okay, so let's just come back over here, and out of our data, you see in this we have the target column, this one. So I'm going to split, first of all I'm going to do the splitting of my data, right? So here let me say target equals to this data frame, and out of this I need to take loan status only. This is my target variable. You see this is what it is, and shape, you see 31,671. Now the next thing, I need to create a list of features. So I would again say this dot drop. So in features will be all features, means whatever input that I want to put in my model to train my model. Okay, so that is the input for myself. Okay, so into this everything except this one, right? So let me just put this comma axis equals to 1. Now let's just see head and how it goes. Well, that does not have over here. Now the next thing is, this is done. Next thing which we need to do is balancing of our data. So for that, this is the library we need to bring in over here, and once this is imported, I will create an instance for this. Smote equals to smote, and this is done. And after that, we need to do the fit transformation. Okay, fit resample. That technique is called fit resample. Okay, this is what we are going to do. So smote dot fit resample, and inside that features comma target. If you want to look at the context, syntax, that is also given over here. X is your features and Y is your target. Now here I'm going to put again, I will after resampling, I'll put it into the features, or let me say balanced feature comma balanced target equals to this features. I'm just trying to give it some sense, that's why I'm doing this. Okay, so balanced features, balanced target, this is done. I will quickly check the shape of each of these two. Now you see the number of records has been increased. Why is that so? And before I explain you, let me see the number of records into this also. So number of records seems to be same in both of these two newly created data frame, and but this is different from what we had over here, 31,671. Now this has increased. Why is that so? Because like I said, look at its name. It says synthetic minority oversampling technique. So the minority class which you had in our case, this was our minority class, right? So what it has done is, for the minority class, it has created some synthetic features, some synthetic data, right? So synthetic data has been created, and that's why the number of records has been increased. So let's consider approximately 15,000 synthetic records it has created for this class. So now this balancing is approximately 50-50. Let's just see if we have the count of this one. Anyway, in both of the things, it has same number of rows, right? It has same number of rows. You see this number of rows it has in both. So this is how it has done the balancing. In majority class, it does some synthetic data creation where it will have all zeros, and in minority class, it will create something where it is all one, right? So this is how it has done the balancing. Now the next thing we are going to do is, now we are all set to train our model. Okay, we will do our model training. So over here, I will not consider just one model. Here what I'll do is, I'll try to build a couple of models. For example, let's say logistic regression is the one, then random forest is something which I will be creating, and a couple of others also we will try over here. Let's just start with training our models. Before we go ahead, now in the previous video we saw the number of records which we got after doing this mode balancing is this much, which is 49,692, while what we had was 31,671. So let me take it over here and try to check it out. What's the case? Okay, so over here what I'm going to do is, my hunch is that I mean, not the hunch, that's what it is, right? Whatever the minority class is there, for the minority class it creates the synthetic records, and for that it uses the techniques called KNN, K nearest neighbor, etc. That's what happens behind this mode. Okay, now let's just see how many the final data which we have got, that is balanced target. In the target column we had we had just somewhere 26,000 of records, right? So in target, if you would see target dot shape, we had this many records. target dot shape, or maybe I should say dot group by. I'm not sure if group by will work on this. Group by, let's see, it is not going to work on this. What we can do is we can directly see on the scale combined, right, for target how many things that we had. Group by, and into this we are going to look at target, okay, and dot size. What we saw was count. What is the problem? It says target is not available. Why? Scaled data combined. In the scaled data I should have target column available, isn't it? In the scaled data I should have this available. Dot head into this loan status. Oh, oops, sorry, my bad. That was named as loan status. Group by into this loan status, and dot size. Let me see how many records that we had got. So you see this many records we had. Now what I'm going to do is, after balancing, what I'll do is I'll just try to have a look on this the distribution. What is the distribution that we have? Balanced target df equals to pd dot, what is od? There is nothing called pd dot data frame, and inside this I'm going to say target, that's the column name, and over here this is what I'm going to use, because this is nd a numpy array, so that's why we have to take it like this. Okay, so this is done. Now after that, again at the same thing I'm going to perform over here also, and let's just put target over here and see. Now what you see over here is, previously in the target column what we had was only 6,825 records were in positive class, and in negative class we had these many records. Now over here you see positive and negative both are in same proportion. That's why we are saying our data is balanced. Great. So now you understood the importance of using this smart, right? It has just made the proportion same, right? So that's where it is going to be very, very important. All right, so what I'm going to do is I'm just going to delete this all, because that was just for the validation purpose. Okay, now let's just see, or maybe I can move it above. Let's just skip it over here, so that in case if it is required, we will have it. Now let's just see, we will start with training our model. So there are a couple of models which I'm going to train over here. Now just stay with me, you would learn a lot. All right, so before we start with the model, what we need to do is we need to classify our data in train test split. Over here we have the set of features and targets. Now we need to classify that in training set and in the testing set, right? So for that, what we need to do is from sklearn. Now whatever libraries and module I'm importing over here, in case if you are struggling to have them installed in your system, just let me know into the comment section. I'll give you a syntax how to install that. Okay, sklearn.model selection import train test split. This is done. Now I'm going to do this split on my data, train test split, and inside this I would be using balanced feature and balanced target. These are the two data sets I'm going to use inside this. Now here I need to specify the test size, means the two let's say if I have 100 record, out of that what proportion I want to use in training the model and what proportion I want to keep for testing the model. So usually what I'll do is I'll do the split of 80-20, means 80% I'll keep for training and 20% I'll keep for testing the data, right? So test size I just need to provide, which I'm going to say 0.20, which means 20%. And then there is one more parameter which we need to specify, which is random state. Okay, So for random state, you can just give any value. Usually, as conventional as convention, people use 42. So I'm also going to keep it 42. Now this is done. Over here, what we need to do is we need to say X train. So this will split the data in 4 parts. Why? Because this balanced features, the input data will also be splitted in 2 parts, and this one will also be in splitted in 2 parts. So that's why we will get 4 data sets. So 2 set I'm going to create for input and 2 set for the target. Okay, not for output, but for the target variable. So X train is my input, means set of features for the training, which will have 80% of the data. X test is again a set of features which would have just 20% of data. Then I'm going to say Y train and Y test. So after doing this, my data set is created for training and test. Let's just see the shape of my data, xtrain dot shape, and over here there's many records we got. And Y train, for Y train, how many records that we have? Same. X test, you see 9,000 records we have, which is pretty well. And then Y test, how many records we have? Again same number of records. So that is pretty cool. We are done. Next thing is we need to build the model. So I'm going to start with logistic regression, which is the very basic one. So from sklearn dot linear model import logistic regression. Okay, now over here I need to create an instance. I'm going to say locket logistic regression. That is what I'm giving a name. If you want, you can give any different name. So this instance is created. Now in this, it takes couple of parameters. It has parameters also inside it. If you want, you can try them, or maybe sometime later we will try to check them out. Now all right, so for now I'm just going to keep it simple. Okay, now this is instance is created. Now the time comes when we need to train our model, right? So for that, what I would do is there is the function which is called locket.fit, and inside this we need to supply the training data. So here this xtrain, this is my training data, this is my features on which I want model to train itself. Means I want the model to understand all these features and try to relate that with the outcome which we have stored in Y train, right? So once this is done, all right, our model training is done. This is done. After this, what we can do is we can do the prediction. So locket dot prediction, and inside that, or maybe we can just try to find the score directly. Score, and xtrain, on xtrain directly I'm going to check the score. Oops, xtrain on Y train, sorry, Y train. What is the score? So it is giving me the score of 78%, right? That is the score it is giving us, which is not very good, to be honest. But yeah, this is this is what it is. And now we can also try to find the prediction. Okay, we can also try to do the prediction. So let's just try the prediction also, right? Now let me say locket dot prediction. So for prediction, we need to give that data to the model which it has not seen previously, and that is available in xtest, for which we want it to do the prediction. Okay, and here I'm going to say log it prediction. This is what I have. This is done. Now after whatever prediction that I have got, this is what the prediction it has given, right? But we would not understand. So let us try to check the accuracy of this and the score of this, right? What is the accuracy and all those things. So for that, there is another module which is called from sklearn dot metrics import classification report. So I'm not going to look into the confusion matrix. I'll directly print the classification report, because that by default gives us the confusion matrix also. Okay, now over here I'm going to print the classification report, and inside that we need to provide, this was the prediction made on xtest data, but what was the actual actual target, actual decision for this set of data. So you remember, for this set of data the actual target is this one, actual response was this one. So what if you look at this, so it says y true and y pred. So y true is y test and y pred is the prediction which we have just created. So let's just supply it over here. First of all, we need to provide y test, and let's just see the score. Now to make it look good, I will do this print. Okay, approximately everything is 78%, right? So pretty much in this sync, F1 score is pretty 78%, accuracy is 78%. I'm just cautious that the model is not overfitted. Okay, so that is also something which we need to consider while building the model. Okay, so now this is done. Now there is one more thing which we can do. Logit dot coef. So you see the coef. Now this is the coefficient for each of the feature, right? And using this we can also decide the importance of the feature, importance of the features. Okay, so let me try to put it let me try to put it on the features whatever we have available in our this data set, balanced features, which is for which is this also, or maybe you can say this one. Okay, so I'll just try to put it in form of a data frame and let's try to see how it looks. Okay, so I'm going to create a data frame called features importance using logit, and over here I'm going to say pt dot data frame, and inside this I would say create a dictionary, and here I'm going to say features, and for this what I have is this data frame balanced features dot columns. This will come over here, and then for coefficient I have this value, or let me say logit importance. I'm going to say it logit importance, and this is what I'm going to supply right over here. Okay, now let me just see how does it looks like. Oops, this is giving me the error. Pre-column arrays must be each be one dimensional. Okay, so this seems to be two dimensional. What I will do is I will try to pick the 0th one. If I'm picking, alright, so now let me just see, this seems to be more than one dimension. Okay, so now this is how we need to pick it from here. Let me take it and put right over here. Now we got this, you see, and over here what I'll do is I'll say sort values. Oh god, this autocomplete takes quite long amount of time, isn't it? Sort values, and by this feature importance, I should have to say importance imp, let's just say imp. Okay, that is fine, that should be more than enough. Okay, and now over here I would say ascending, god, ascending equals to false. Here we go, right? Now what you see is anything around 0 may not add much value into it. So now you look into this rent is the categorical one which we had just done 0 and 1. So that's something which we can ignore. This is also we can ignore. These all are the columns which we can ignore. Okay, no, not to ignore. This is actually important. This is approximately something something of importance. What can be ignored is this may be ignored. Person employment length, person age is something which we, this is something you see it is not adding much value. Credit history length, you see it is just 0.018. This is something which is not adding much value, so we can think of dropping this feature. But for now I'm not dropping anything. So what I wanted you to understand is, see, this is how you can you can check out the importance of the feature, and basis on that you can do the selection. So this is very, very important. Loan percent income, which is nothing but debt income ratio, and the let's say top 5 we can pick out of it, right? So 1 2 3 4 5, this set of columns could be very, very important, this, and then these are also something which are very crucial. Okay, these are something which we can consider in our model. But for now though, I'm not going to drop any of the model, and I'm going to keep all of them. Okay, next we will again see, we will try to do this thing on other model, and then we will see. So logistic regression is done. Logistic regression is done, and its prediction is stored over here, right? Now let me just try to train another model from sklearn dot ensemble. We have random forest. Import random forest classifier. So this is what I'm going to try over here. Now let me try to have a checkpoint over here. Random forest, I'm going to say it random forest. This is done, and again over here what I'll do is I'll take this random forest classifier, and I would create an instance random forest. Done. Inside this we can put number of estimators, means number of trees also, how many trees that you want to train. By default it has 100. I'm going to go ahead on the same, but we can of course change the number of trees. Okay, now rf dot fit, and inside this again I'm going to supply xtrain dot comma y train, and let's see what happens. Okay, this model fitting is done. Once this is done, then we will perform the prediction again, all those three things which we had done previously. See, it is taking time because 100 trees we had considered. If you want, you can choose less number of trees. And what you should importantly notice is, here is the one place where we did the classification, and we are using the same classification in all of the models. So you see it is taking slightly more time because it has number of trees which it has is huge, and it has to train each of the tree. So if you are someone who do not understand what exactly happens in the random forest, do let me know. I'll create a separate video on that. Okay, now this is done, and I'm going to find the score, and inside this xtrain y train, and let's see what score that we are going to get. Ooh, it is 100%, man. It is saying all the predictions are 100% correct. Oh god. Okay, what I'll do is over here this logistic regression prediction, logit prediction, I have already stored. At the end I will be creating a data frame in which I would have all the predictions available. Okay, now this is this says 100% correct. Now next one is I'm going to do the prediction, rf dot predict, and inside that I'm going to put x test, of course, and let's just say prediction rf prediction PREDIC, spelling was incorrect, prediction, and this is done. Let's just see what we get. Okay, here also the prediction is done, and it says the accuracy is 100%. Now let's just try to print the classification report, and inside that I'm going to put y test and then rf prediction. Again I need to do the print. All right, so on training data it showed us the score as 100%. On test data it is coming to 94%. The accuracy is coming to 94%, you see, and f1 score is 93% for this class, minority class, right? For minority class, the F1 score is 93%, and majority class it is 94%. So it is pretty much in balance, right? Accuracy is also 94%, so it looks pretty much balanced. Now over here also you have feature importance. Here also we will try to get the feature importance. So now I think you have understood, and now the next thing which we are going to do is we are going to find the feature importance. Rf dot feature importance. Let's say feature importance. Here is what we got. Okay, all right, this seems to be one dimensional or two dimensional. It is one dimensional. Okay, this is just one dimensional. Now I'm going to create another data frame for this one. This was for logistic regression. Next one I'm going to create for this one, random forest. Now if you're getting confused why over here I took 0 and into this I'm not taking that, the answer is here it is one dimensional only, into that over there it was two dimensional, that's why I had to pick one. Okay, and here I'm going to say RF random forest importance, and let's just see how does this looks like. Here also I need to say RF. Thankfully I just noticed it, otherwise. Okay, we got this also. Now I'm going to say sort values, and inside this by RF importance ascending equals to false. It takes a lot of time to autocomplete. Okay, this looks pretty well. So these are something which are of less importance, but remember these are the features which we had which were previously as categorical columns, but later on we made that as a feature, part of the categorical column, right? So these are looking to be of less importance. What is more important is loan interest rate, which is absolutely 20. I think if you put it in terms of percentage, it is 20%, right? And then loan percent income is 19%. So this is how it is looking, huh? You see, these are pretty good estimators. These all seem to be pretty good estimator. This is also, so it is close to 1, but these are too far from being 1, right? So I think in our input we can consider not to include this. Okay, what we will do is after training all of the models, we will combine all the features and we will see how each of them has performed, and then accordingly we will try to come up with a better set of the features, and then try to do the train test split, and then further try to train our model once again. Okay, now this is also done. Next thing is I would also try to train one XGBoost model. Okay, now let's just make it XGBoost. XGBoost model. This is also done. Now again over here what we need to do is we need to do the import again from XGBoost. Let me see, XGBoost import XG classifier, XGB classifier. We need to import this one, XGB classifier. Okay, now for that again I would require to create an instance XGB classifier, XGB model. I'm going to say it XGB model equals to XGB classifier, XGB classifier. What is the difference? Okay, XGBR classifier and this is XGB classifier. Now into this we need to put the X and Y, but in little bit different format, I think. Here there is one thing which we need to consider, and that is there is one method which says exact, and that's what we require over here. tree method. I'm trying to find, there is one parameter which is called tree method. Here you see tree method we have. So this is something which we need to specify over here. Tree method, tree equals to exact. Let's see if it gives any error. So seems to be correct, but somehow it had a struggle to do the completion. Okay, now after that this instance is created. Now the time comes when we need to train this. So I'm going to say xgb.fit, and inside this we need to supply the features again. So they here when we are supplying, one thing you should note is here x value you can supply as it is, so which is nothing but x train. And over here y value, when we are supplying the y value, what we need to do is we need to say y train dot values dot ravel. That's what, right? Now it will do its training on the train data, and then we will try to find the score of it again. Ooh, now you see over here it is providing you all the details. Base score is 50%, booster GB tree, gradient boosting tree has been used over here. Learning rate is 30%, maximum bin is this much. It is providing you all the parameters. So it has also used 100 trees. If you want, you can increase or decrease this number of trees. Minimum child weight was 1, maximum leaves were 0, and maximum depth was 6. So if you want to understand any of the parameter out of it, do let me know. I will try to create a separate video again for that also. Now the time comes when we should check the score of this score, and into this we are again going to put these values. 96%, score is 96%, you see. Now I'm going to make the prediction over here. So XGB model dot predict, and inside this what we need to put is x test, and let me store this inside this prediction equals to this, and let me just try to print it. Okay, we got this one also. Now the time comes when we need to check the accuracy score on this. This is the data which model had not seen, and this is what we are going to check for the accuracy score. Again, I will print the classification report, and inside that I'm going to put XGB prediction. But before that, I need to use the truth values. Okay, and let me just print it. All right, so this is pretty close. On the training data it was giving us 96, and on the test data it is giving us 95, right? 95. So this looks pretty well, right? Because if you remember, for this model, this random forest, on the training data we were getting 100%, and on test data it was reduced to 94%. So my suggestion is, I mean, if you ask my thought, then my thought will be this is better than XGBoost is better than random forest, because on both of the model it is approximately performing the same sort of similar sort of it is giving similar sort of accuracy. Okay, now usually any difference below 10% is considerable. So from that perspective this also looks okay, because here on training data it was giving 100%, and on testing data it is giving us 94%. So this is also pretty well. But over here this looks very close, right? Because for training data also it was 96%, and for here it is 95%. So this looks very close. Now again the time comes when we should separate the feature importance out of it. So I'm going to say xgb model dot feature importance. Okay, and let's just see, this is also one dimension. So now I'm going to put it in a data frame. Okay, Now to put that in the data frame again, I'm going to say XGB importance. Okay, what was the previously how we had created the data frame? Feature importance RF. So let me keep the naming convention same so that it does not create any confusion. XGP. Okay, and over here I will say PD dot data frame. Inside this, let me copy paste all of them from here directly so that it will save time also and we will be able to quickly do it. Everything is done. Let's just copy paste this part over here, this many part. That's it. This is done, and over here let's just close this curly bracket and let's just print. Oops. This is also closed, and let's just print the head. Very well. I'm going to say sort values and sort values by equals to, oops, not RF importance, rather it should be XGB importance. XGB importance. Okay, otherwise the data will be confusing. Okay, and here I'm going to say ascending. Oh god, why did I hit tab? False. Let's see. Okay, this looks pretty much in sync with our random forest, right? Now, so here we got this data also. Next one, what I'm going to do is I'm going to concatenate the feature importance which we have received from all of the three models. Now over here, feature importance data frame pd.concat, and inside this I'm going to put all of the features. Let's just try to put all of the features. Where is that RF random forest importance feature? I'm going to let's just start putting it one by one, otherwise it will be a mess created. Here this one, comma, RF feature importance RF, and then feature importance log it. So all the three are done, and here I'm going to say access equals to 1, and over here let's see how it looks like. Oh, we got, the only challenge is feature we are getting again and again in all of the data frame. We can for now let's be with that, and then later on we will see what to do with how to manage that. Okay, now what is it that we got to see over here? Person age. Logistic regression is telling you that it is approximately 0.06. This is also RF model is also saying 0.06, and this is, so these all seem to be in pretty much sync to drop the person age. Person age is something which we can exclude. All right, next comes person income. Here RF model is saying it is more important, and XGB model is saying it is less important. Okay, and logistic regression is also saying it is approximately less important, right? So we can think of dropping this as well. Person employment length is something, it is saying 0.04, 0.07, 0.04. XGB model and logistic seems to be quite in sync, isn't it? So now this is also something which it suggests can be dropped, because two models are showing it less important. This one 0.69, and here it says 0.08, 0.008. So again, these two models are not recommending this particular feature, loan amount, but I think we should keep it because this is a critical thing, how much of the amount is needed, right? And I can't say that it is less. XGB model is saying it is absolutely, you know, not much important. It is 0.008. It is not much important from the XGB model perspective. Loan interest rate, loan interest rate, RF model suggests it is very, very important. And then logistic regression is also, it is suggesting it is very, very important. Logistic, I mean, interest rate is something which should be important, which should be considered as an important feature. All right, from XGB perspective, which one is the most important? Loan percent income. Loan percent income is important for all of the features, from all of the models perspective, right? So you see, that's why it says debt to income ratio is very, very important, right? Debt to income ratio, in fact it is, because that gives very good insight. Then over here, this is the one, and then the next one is this one, own, whether the flat is own or not, that has also played a critical role from the XGB model perspective. So it says 0.17 and 0.02, and here it says -2. So that means from logistic regression perspective also it is very, very important. All right, so this is how you can find the importance of the feature. What I'm going to do is I will combine this prediction with my original data. So the original data, when I say, that means just before, when we started with treating the categorical columns, right? I mean the point when we finished cleaning of our numerical values. So if you would see over here, categorical features treatment, just before that, into this data we were done with, imputing the missing values and removing outliers, etc. So in this data, whatever prediction we made with logistic regression, random forest, and XGBoost, all of those three predictions I'm going to combine with this data. Okay, credit credit data, this is the data which I'm going to use to combine all of those prediction with, concatenate all of those prediction with. Rather, I would use this one. This is the copy of that. Okay, in this one. Now, before I start with combining the things, what we have to understand is the shape of the data. You see, this particular data was imbalanced, right? After after having this data, the operations which we performed, we did the one hot encoding, which is get dummies, right? That will not create much difference in the dimension of the data, that is okay. But when we are trying to put the prediction in, then we are trying to put the prediction in absolutely original data, where this is not treated in one hot encoding, because this is what will make sense to your senior management. They will not understand 0 1 etc for all of those features. So it is always important to keep it in more practical format. Okay, so this is what your senior management will understand, that this is type of the loan. If you put it in one hot encoded format, they will not understand. So that's where I'm going to do it. I'm going to bring my prediction into this particular data frame. So what we have to understand is the shape of this particular data frame was different. What we did is we took this, then we did one hot encoding. That will also not change the shape of the data. We did scaling, that will also not change the shape of the data. But we did smooth balancing, the data balancing with smooth, and over there we had observed that the balancing act had increased the number of observation, number of records, right? You see over here, that has increased the number of records. So in that case, how would the merging will happen? That's something I'm going to explain you with the help of an example. So consider this is our original data just before we started treating the categorical column. Now in this, what you see is 7 records are, I mean, I've just taken hypothetical numbers just for the understanding. In this data set, we have 10 records, out of which 7 are negative and 3 are positive. Now, when we do the balancing, So when we were doing the balancing, what it did was it created some more synthetic data for the minority class to make it equivalent to the majority class. So in majority class we had 7 records, and in minority class we had 3 records only. So smooth balancing, what it did is it created 4 more records to make it equivalent to the majority class. Now we have majority also with 7, and minority uh, which previously was minority, now it is not minority anymore. Now this also has 7 records, and the indices were added onto it. So now what you should notice is the balancing act did not made any change in the already existing records. What it did is it created some synthetic data and it appended into that. So this indices corresponding to its original data remains same, no changes has been made into it. Okay, so that's something which which you should notice. So you might notice that I have, while explaining this part, I have skipped the scaling. Why? Because scaling had not created any difference in our data, but when we are merging prediction with our original back with our data, we are not going to merge with the scale data, because the scale data is not making much sense, is not something in the format which senior management can understand. So that's where we have to merge it with very original data, which was this, which has the actual name of the products and everything, right? So that's something which you should notice. Just ignore the scaling part while we are talking about this merging. Focus on the original data, come to the balancing part. So in the balancing, what we saw is this number of records have been created. Now think about the training, when we did the train test split training data, right? In training data, what had happened, whatever data we created after smooth, out of that 80% were placed into the training and 20% were placed for testing. For example, let's take this one. Okay, so into this, what might have happened is, in while doing the train test split, this is what might have happened. Okay, let's say this is the split which has happened. Okay, this, and let's take again this over here, right? And this again over here. How many records are this? Are these 7? Let's put one more over here. So I have not taken exactly the 30, exactly 80%. It's just consider I'm creating an hypothesis. So that's where I need you to just understand that this is approximately 80% of the records. Okay. Now the remaining records we had in test. So in test, what we might have had is this. Then let me just quickly do this part so that we will get the list very, very quickly. I will just exclude this. Okay, so all of these records are something which we would have over here in the test part. Okay, this. Now let me just delete this. So these were the test and these were the training. Now just 1 second, I'll bring it down one more, and then this is how it is. Okay, now when we did the prediction was done for this set of data only, right? Prediction was done for this part. So over here you see pred outcome. So this is what, let's say in prediction we might have got this, right? This, and then 0, then this. Okay, so this is something which we would have got. Now in the prediction we have only this thing, right? Now how to merge this with this one? We have to merge this thing with this one. So remember, what Python does is Python never alters the indices. It never does any alteration in the indices number. Okay, index numbering, it never makes any alteration. So whatever prediction that we have, for this what we will do is we will map this prediction against these indices which we have in our test data. So we will make it something like this. So you see, this is the original defaulters flag, and this is the predicted defaulters flag. Okay, don't get into the accuracy and exact number, just let's just consider it as of now. And this was the index. Okay, now once we have this prediction mapped with this test data indices, what we can do is, now we can, basis on this indices, we can directly merge with our original data, something like this. Over here we will do this, and we will come back over here and we look up, and the output which we will have is something like this. So you see, wherever we have hash NA, that means those were not considered, those were not part of the test data, that's why we don't have it. So we would have the prediction available for only those records which were part of the test data. And this is how we can come up with the prediction in our original data set. So we would require, when we are presenting, we would require to exclude this while we are presenting, and we would require to include these observations only in our presentation. So I just hope that it was clear to you. In case of any doubt, put that into the comment section. So this is exactly what we are going to do. We have this prediction from 3 models. For each of the prediction, we are going to add it with the indices and then merge that back with the original data frame. Okay, so let's just get back to this work. All right, so first thing which we are going to do is, we have 3 predictions. Okay, where we have the predictions stored. Predict XGB prediction. So we have XGB predictions available. Let's start with XGB prediction. XGB prediction. Okay, so we need, so currently what we have is this array. We need to convert it, like, we have to convert it in the form of data frame. So what we are going to do is, I would say pd dot data frame, and inside this I'm going to say, let's just say, let me just cut it for now. And over here, what we require to, first I'm going to say test, or test indices. So test indices which we had was in x test dot index. So from here I will take the indices and I'll put it inside this. Then the next one which I'm going to do is XGB prediction, XGB prediction, and over here this prediction goes in, and I'm going to enclose this in the parenthesis operator, and here I'm going to say XGB prediction df. This is what the data frame I'm going to create, and let's just have a look on this. Wow, we got it right. So these are the indices, and this is the XGB prediction. Okay, now the next thing which we are going to do is, same thing we will repeat for each of the models. Okay, now let's say logit prediction underscore df, and after that I'm going to use this one, and over here what I'll do is I'll take this and I'll just put it over here. This is logistic regression prediction, and then there is one more which we need to put, that is random forest, rf dot prediction underscore df, and this is what I'm going to do, this, and over here this. All right, this is done. All of the 3 things have been created. Now after this we need to do the merging. We need to merge this with original data frame. So the original data frame name was this, cr data copy. So I'm going to do this, cr data copy dot merge. Before that I'll create a copy of this, merged with original. Okay, and over here I'm going to say this, comma merge. Inside this, one by one we will do the merging. XGB prediction df, comma. Now when we are doing the merge, so from this I want to take the indexes in these 3 predictions. We have 2 columns. First column is for indices, second column is for this thing. here I'm going to say, let me just name it something like XGB, XGB, and so that I could differentiate it at the time of dropping RF, and then over here I'm going to say log it. Okay, now if I have to display it, so I think that should be pretty simple. You see over here we got test log it, then we see this one, we have this RF, and then this one. So pretty simple. Okay, now after this what I'm going to say is index left index equals to true. So what I'm saying is simple. From this data frame I'm asking that you take the index column, index as the key column to make the join, and here from the right hand side, right index, first of all I'm going to join with XGB model, XGB predictions. Okay, so from here I will take this one. This is done, and how I want to do the merge, I want to do it left merge, left, and let's just see how it looks. Okay, there seem to be some issue. Left is not given. Okay, I need to put it in quotations. Now what's the problem? Right index parameter must be of type boolean. Why? No, this is here I need to say right on. Okay, this is done. Now you see over here it says NaN, which means our left hand data side do not have a record for this one. Okay, I mean there is no record available in XGB pred for this original record, so that's why we are saying NaN. You remember this part, okay, where we don't have the match, we will get NaN. So I think that is pretty much fine. Next joining again we are going to do on top of this. So I'm trying to keep it simple, that's why I'm doing the joining in multiple form. Okay, and over here I'm going to say merged with, next one I'm going to merge with random forest. Okay, now I will take this whole data from here, and instead of this I would consider this data frame. All right, and over here what I'll do is I will use RF prediction df, and let's just see how it looks. Now in this data, one thing you should notice is this part. Okay, indices, this is something which I would be dropping at the end, not now. Okay, and let's just see how it looks. Dot head. Again there, oops, here I need to say RF. We got this one merged. XGB pred, why is this thing XGB pred y, XGB prediction x, there seems to be something wrong. Why it would have XGB prediction twice? I don't think it should have the XGB prediction twice. Merged with RF prediction df, merged with XGB pred, merged with the original. This is what I'm choosing over here. Test indices XGB pred, test indices RF, XGB pred y. Okay, I think there is some problem while I was creating this data frame. Over here you see this is something which I did wrong. Here I should say RF, and here I should say log it. So that's a silly mistake which I had made, and now you see how it can cost you the double effort, right? Now this is done. Next one again I'm going to do the next merge, and this time I'm going to do the merge, I'm going to say it final, and over here I will use this data frame. All right, and over here I'm going to use log it prediction data frame. Okay, and over here, what is the one that we would be having? Right on RF, and here I think it will be Logit. I think this is what I had written over here. Yeah, this one. This is what I had over here, and now I'm going to see these final. This is done. Oh god, this is looking more pathetic. I don't know. Okay, now this is done. Let's just try to check the shape of this data. Dot shape. So you see, you remember this was the original number of records which we had in our original data frame. Let me try to see if it is printed somewhere at the top side. It must be, certainly. Yeah, you see over here, scaled TF we had 31,671. So into that we have got this merge. Next thing which I'm going to do is I'm going to drop the null values. Okay, so drop this. Is there something which is called drop NA? Drop NA, and let's just see what happens. That is done, and we are left with just 217 rows. So this would have dropped negative blank values wherever it was null in either of the columns. So all of them has been dropped. Okay, so this is how it has been merged. Now we are left with 273 rows, and that's what we are going to utilize in our presentation. Now we got the prediction for 273, right? Now don't think that after putting so much of the effort we got the prediction for only 273 records only, because you know, over here there are multiple steps taken in balancing and all those parts, right? So if you now once your model is trained, what you can do is you can again take the original data and you can put into the procedure and you can get the prediction on whole data, and then you can merge that. So you don't have to worry about it. It is just a sample. So if it is needed, what we can do is we can take the whole this whole data set, this one, we can do the treatment, all the necessary treatments, which includes one hot and all those sort of cleaning work. And after doing that cleaning work, this time we don't need to I mean, we can of course do the scaling of the data. Okay, and we can this time when you are once your model is trained, you don't need to do the balancing again, because that once model is trained, of course you will be using that on unseen data. So you just do the scaling, and after doing the scaling you can directly use that into the prediction. So next time when we do the prediction, we would have this thing available for whole set of data, which we will also try. But for now what I'm going to do is I'm going to be focusing on this part of the data only, right? But I highly encourage you, what you do is I mean, after once completing this analysis, we will automate this process, right? And after automating this process, I would encourage you to use that module on whole set of data and try to create the prediction. We will also try to do that, but for now let's continue with this 273 records. Okay, now I'm going to take this 273. Let's just have a view on this loan status. Okay, we need to do one more thing, and let me just see if what is this thing that we got over here. Okay, here it is giving us the whole data set. So here what we need to do is we need to say in place equals to true. In place equals to true. Okay, now if you see over here, it will always give us 273. This is done. If you want to see the head of the data, this is it. And if you want to see the shape, that will of course be available, which we just observed. Now out of this, I also need to drop these three things, this, and this. These three things I need to drop. So after this, I'm going to say drop this set of columns, because this does not have any value addition in my final analysis. This is XGB prediction, I'm going to keep that. Then next one is this, and after this what I will do is I'll drop this data frame also, sorry, not data frame but the column. Okay, and axis equals to 1. I'm going to say final data with prediction, okay, and let's just say head. There is one more mistake which I was going to do, and this is this. Okay, now let's just see this is final. After this I'm going to export this into Excel, and where I'm going to keep my Excel is in here, and for that this is what I need to do, and over here I say pd prediction dot xlsx, and here I would say index equals to false, so that it does not give me the index in the final data. I don't require that. Okay, PD prediction, this is what we got. It's opening up, don't worry. So here is the data we got, and let's just try to compare. Okay, loan status is this. I'm going to take this and put it right over here so that we could do the comparison. Now this loan status looks pretty much in alignment with XGB model, and less with pretty much with XGB model, and less with this ref prediction and logit prediction. Let me try to freeze pan, and you see over here very well. XGB model is doing pretty well. You see this was the true where it has made the mistake, but overall it is doing pretty well, isn't it? And you see this RF prediction, which means random forest, this is doing relatively this is doing better than logistic regression. Okay, which was apparently clear when we were making the models. Okay, so now you see over here this is also good. Here model has made the incorrect prediction, but XGB has done the correct prediction, but these two have made incorrect prediction. So you see how good the prediction was now. So this is done. Now I'm going to take this into the Power BI, and after bringing that into Power BI, we are going to make some analysis and see how the things has worked upon. Let's just try to put it over here. It's just taking few moment. Now I think we have our data available over here. Now the time comes when we need to create the visualization. Now the next, like I said, the next step will be to try to visualize this in Power BI. So that is precisely for the purpose of model monitoring. So what happens once we are done with developing the model, right? After developing and testing and doing everything, we do the validation also, and then we deploy it. And after the deployment, we have a process where the people monitor the performance of this model, right? Performance of the model. So that's precisely called model monitoring. Okay, so for model monitoring I have tried to create a tentative dashboard. This is the one which I have created. Now this is a very tentative one. There are many other KPIs which are included into the model monitoring dashboard, but this is something which is good to start with. Okay, so if you see over here, what I have included is this is the confusion matrix, this is accuracy percentage, and you remember in the previous video what we had done is we created three model: linear regression, random forest, logistic regression, random forest, and XGBoost. So this monitoring dashboard is for logistic regression. All right, so you see this is accuracy and this is precision recall F1 score for the positive class. Positive class means where it says that the that particular account was default, and this is for negative class where it says that the account is not defaulted, right? And here I have tried to display the actual default status by home ownership status, and this is the prediction. Here what I have done is I've tried to show the prediction against the actuals by person income. For example, if somebody is earning 100k, then what is actually the default actual default, what was the status of actual default, which was 1, and what was the predicted, that was 1. So here we are precisely mapping, right? Over here what I have tried to show the same thing but by debt to income ratio. Okay, so this is a very tentative dashboard for model monitoring which I have created over here. Now what you see, there are a couple of things. What you see over here is 55% is the accuracy score, precision recall is are these, which you might notice is quite less than what we saw just after training our model when we had tested it, right? Over there it was pretty high. So that will be obvious because when we merged the prediction back with the original data, many records were removed out of the data. So that will happen in this particular data, but don't worry, when you use that model on another data, you will be getting approximately near prediction on the fresh data which you have, right? So you don't have to worry about. Now to understand this well, why this is happening, what I have done is here I have also created a dummy data set and on that I have tried and tested the same thing. Like you can see, when I merge that back again, I got many missing records, right? So that's something which I have done over here. For you to understand it well, I would highly recommend you to go through this. I'll provide a link of this notebook also. I'll highly recommend you to go through it to understand the differences between both, right? So like you can see over here you're seeing accuracy score 75%, that gets reduced to 67% after merging the data. You try to have a look into this and try to understand why is this happening. That is very important. All right, coming back over here, now there are a couple of things. Precision recall F1 score, which we have been talking about. Now if you want to understand what is the formula used for calculating this, there is a video which I have created, this one, right? You see precision equals to true positive out of all predicted positives, means the all the positive outcomes which we received from our model, out of that how many were actually positive. That is what we try to find in precision. And in recall, this is what happens, means how many actually were positive, and out of that how many were correctly predicted by our model. That's what is recall. And now if you see, if you proceed little further, here you will get the formula for F1 score. All right, so I highly recommend you to give a watch to this particular video and try to understand. In case of any doubt, of course you can put your thought in the comment section. I'll definitely try to get back to you. Okay. All right, so now that we are done with doing the initial discussion, let's try to replicate this same dashboard but for XGB model outcome. Okay, this was developed for logistic one. Now I'm going to replicate the same for XGB, right? So here I have another Power BI window open, and here I have the same data available. Now to start with, couple of the measures that we require to create, which are, accuracy score, and then precision recall F1 score for positive class as well as for negative class. So let's just quickly start with creating the accuracy score. All right, so let's just say new measures, and here I'm going to say XGB accuracy. All right, and here what we can say is calculate count rows, and here I can say filter. So what exactly that we need to do over here, I mean, how many were where the total number of records were same, right? I mean, not the total number of records were same, means outcomes were same as actuals, right? So if you precisely want to understand, what I'm trying to say is logit accuracy. You see over here what I'm precisely saying is loan status, which is the actual status, is equal to log it prediction, right? So this is exactly what we need to find out. Okay, so over here I'm going to say again, let's say table name is prediction, and then over here the loan status, it must have loan status. This is my actual outcome, when I mean actual flag, whether the account was defaulted or not. If this is equals to, uh, predicted, XGB predicted, right? Sorry, XGB pred, right? Then this count of rows divided by count of rows of total count of rows, how many total count of rows that we have in our prediction table, right? This is what going to be our accuracy score. Now to see this, what I will do is I'll quickly create a card over here. This is the one which I'm going to create. Just right over here, and XGB accuracy. Let's just see what is the value that we are going to get. It shows 92%, and let me try to convert it to the percentage format, percentage. Okay, it is 91.94%. I'll do, because we have already created it, so what I'll do is I'll do a bit of formatting over here quickly. Visual border, yes. Okay, and from here what I will do is, here I'm just going to rename this, rename for visual. Here I'm just going to say XGB, sorry, accuracy only. Okay, now to validate this, how true is this we are getting into the Power BI, what I will do is I'll quickly try and create the classification report on this filtered data. Okay, so let me just say print classification report, and inside that I'm going to supply this one, out of which I will take loan status and comma the prediction which I have, final with pred, and here I'm going to say XGB. Here is the one, I will rather copy paste that. Okay, let's just see. All right, so here it says 92% accuracy. Here is approximately the same one, right? If I round it, it will come to 92%. Okay, so we are good with this. Next one, we require to create precision recall and F1 score for both of the class, positive and negative. So let's start with positive class. So I'm going to create a new measure where I would say it's a little bit slow. Let's just bear with it. So here I'm going to say XGB and precision positive class. Okay, and again here again we are going to say do the same thing, calculate count of rows, filter. So what exactly that we need to find? First we need to find the true positive. So true positive means where model predicted positive and that was actually positive. Okay, so let me just say first prediction, and out of that I'm going to say loan status was equals to XGB, loan status was equals to 1 and XGB prediction was also equals to 1, right? So this will give me the true positive. Now after finding this, what we need to do is we need to divide it with all predicted positive, right? Let me show you the formula once again over here. If I bring you back a little bit, all predicted positive. So what I will do is I'll close this one, divide by again count rows, and then again here I'm going to say filter, and then table name is prediction, and out of that we require to find the predicted positive. Okay, so what I'm going to say is XGB prediction equals to 1, right? So this will give me the number which I am looking for. I mean, this will precisely give me the positive, precision for positive class. Okay, let me just see. And then again, I'll create a quick card. I'll create another card over here, and let me just put this one XGB precision over here. It says 96%. We will just have a look how close it is. Let me just make it to the percentage. I know it's a bit slow, so if you guys want, you can just watch this. I highly recommend you to watch this video in in this format. I mean, at the speed of 1.5. Okay, that will work better. Okay, so over here I'm just going to set the border for this again, visuals border. Okay, now let's go back over here and see what is 96% for positive class. 96% for positive class. This is good. Now the next thing which comes is to create the recall. Now for the recall, everything is going to be same. It's just we need to change the denominator, right? So previously we wanted to, in precision, the formula was to find out the proportion of true positive out of all predicted positive. Now here you see numerator is same, just denominator needs to be changed. So let me just create that very quickly. New measure. It's Power BI's fault, not mine fault. Okay, precision, and after that here I'm going to say recall, and just over here I will just change this part. Okay, now over here what I'm going to do is I will say loan status equals to this. That is it. XGB for positive class. Okay, sorry, recall for positive class, my bad. Now let's just see. Let me bring it over here, and out of into this I will put this one. It says 68%. Let me again convert this, and from here I will make it percentage. While it is processing, let's jump back to the Jupyter notebook and see 68%. Recall was 68%, which is pretty good. We are in sync. Now this is done for the for the positive class. Next thing which we require to do is find the F1 score. How do I fix this? Effect. Here is the effect and the visual border. Okay, now the next thing which I'm going to do is find the F1 score. And for F1 score, what exactly that we need to do is, let's have a look on the formula again over here. A little bit more. 2 into precision into recall divided by precision plus recall. Okay, so let's just create a new measure over here. I think this is precision, this is recall. I don't know why I created this. Okay, into this one only I'll utilize the I'll try to put the F1 score. Okay, I just duplicated it. Sorry guys for this. Now let me just create F1 score. It's pretty slow guys, you need to bear with it. I just wanted to give you a real feel of the development. That's why I'm doing it one by one. Otherwise I could have just copied pasted it, right? And here I'm going to say XGB, then F1 score, and that's for positive class. Okay, so what exactly that we need to do is 2 into inside this precision into recall divided by precision plus recall. So what is the KPI name that we have already, what is the measure that we have already created? This is the measure, XGB precision positive, right? So let's just say XGB precision positive into XGB recall positive. This is done, divides by XGB precision positive plus XGB recall positive, right? This is what the function was. Let me just do this, run this. I'm just concerned how long this video is going to be. It's been already more than 5 minutes. Now let's just make this into the percentage. While it is processing, let's go back to this one and let's see. No, not this one, but the Jupyter notebook. The F1 score was 80%. Let's just see what is it that we have got. Ooh, this is not correct. Actually, 273% is not possible. All right, why is that so? Because these were already in percentage. Is that the reason? It says precision into recall divided by precision plus recall. What could be the reason? Let me just check it out if there is anything which I have missed over here. F1 score, F1 score for positive class. Here's the same thing. Log it precision to log it recall divided by logistic regression, logistic precision divide plus logistic recall. What's the problem, guys? All right, I was just missing one bracket over here. This is the bracket which I was missing, so I just put that bracket and it is done. Right, so precisely this part was also supposed to be, the denominator was supposed to be in one bracket, so that is done, and we have 79.63% of the F1 score. This is we got. Now the same thing, I'm going to pause the video and create the same thing for negative class. I am just trying to keep the video precise, that's why I'm just going to pause the video and I'll create the same thing for negative class also, and then we will resume. Alright folks, now here I'm done with creating these 3 KPIs for negative class also. Like you can see, precision which I'm getting is 91, 99, and then the F1 score is 94. Let's just compare it, 91, 99, 90, 95, so which is 94 point something, right? 94.98, almost 95%, okay? Next thing which I'm going to create is the confusion matrix. So for that, what I'll do is I'll take this and into this on this is matrix, okay? On row level, what I'm going to do is I'll put loan status. Let's just put it on row level. On column level, I'm going to put XGBoost. XGBoost. Why it's showing some? Okay, let me put it in column level. We got that. Now any of the variable we can put over here, because simply we need to take count of any of the things. So let me just put XGBoost only, and here I will change it to count. Okay, so this is what we got. Let's just try to check it. How close is this? Okay, now here I'm going to say confusion matrix. Oops. Looks like I have not imported it. Let me go at the top of the code over here. Oh god, now where is it that I have imported? Okay, irrespective of wherever I have imported that, I'll import it again. Okay, now over here from sklearn.metrics import confusion matrix, and here I'm going to say confusion matrix into this. So not into means inside that. That's exactly what I was looking for. Let me do this. Okay, you see 208 to 2043, 208 to 2043. So we are pretty good with this also. Okay, formatting part is something now we will just do it. We will do the formatting part for these many KPIs, and then after that again we will take it further. Okay, so again for this one, effects border this. Okay, so what I'll do is, for formatting part, I'm going to copy the formats what we had created for logistic regression, so that I could keep it in line also. Okay, now here a couple of things. I don't want to show the columns subtotal and row subtotal. Okay, to keep it precise. And the design, if I have to see, there are some preset designs: grid, column subtotal, specific column, style preferred. Okay, and here minimal is the one which I'm going to keep. Okay, and column and row we can keep bold. So first of all, let me just go back over here, and how we can check out the design of it. So precisely, let's just collapse that and expand this one. Okay, I don't really require to see that. Okay, let me just click this visual. All right, now if I come back over here, go in this, and for dimension, what I need to see is, you see size is height 140 by 190. Let me make it 140 by 190. 140, and over here I'm going to say 190. So that is pretty much measured. That's why I'm trying to copy the same thing as per the dimensions. Okay, now column headers I need to make a little visible. I need to make it visible a bit, so that's why I'm going to do this. Column header bold. And what is the column header that we have over here? Column header 15 bold, right? 15 and bold. A row label is also the same thing. It should be 18 and bold. So column header is 15 and bold. All right, now comes the row header 18 and bold. It's completely your choice. If you want, you can keep whatever the value you want to keep. Right now, next thing, a little bit in values, I'll just try to copy what is it that we got in values. 11, right? In values, I need to just see where is the value. 11. I'm just making it a little bigger, right? So we are pretty much sorted with this. Now the time comes when we need to see the accuracy box. Accuracy box is what? Let's have a look on dimension. 140 by 130. Let's make it 140 by 130. 140 by 130. Property 140 by 130. Height was already correct. And naming convention, I will just, oops, I think I make a bit mistake. Precisely, this one was supposed to be 140 by 130. 140 by 130. This is done. And what is the status on fonts and everything? Let's just see this. Call values. This is 42 and no decimal values shown. 42 is call values and category 18 bold. This is 42. Decimal places, no decimal places. 42, little bit small. Okay, now this has to be 18. 18 bold. Perfect. This is done. Next one is, next we are going to be with all these 6 boxes. All the 6 boxes are of same size. Let's see. Properties, general, properties, size 90 by 158. I think it is 90 by 158. Okay, 90 by 158. Let me just make this all 90 by 158. 90, 158. Okay, this is also done. And what else? 90 by 158. Is that correct? 90 by 158. properties 90 by 158. This is super. Next thing which we require to do is the font part. Okay, for values I'm going to remove the decimal places. I know the video is turning out to be bigger, right? So you can feel free to, you know, skip this or maybe watch it in fast forward mode. That's going to be absolutely fine. 20 and bold, both of the two things has to be 20 and bold. 20 and bold. This is also has to be 20 and bold. Oops, it looks okay. Renaming is also something which we require to do one by one. Let me just do it very quickly. Okay, before that what I'll do is I'll just arrange them, otherwise I'll forget. I might forget whether that is positive or negative class. Okay, so that's why I'm thinking to first create the text boxes. Precision positive. Okay, can I copy paste this? I don't know. No, I don't think I can copy paste. So let me take this and create positive class, and this I'm going to make bold. What was the size? Font size 20, bold Arial 20, bold, and this is Arial. Done. This is also done, and it has to be in center alignment. And what is the size of this box? That's something which I again need to check from here, and I will just go back over here. God, what's happening? Properties 50 478, 50 by 478. I need to make it 50 by 478, 50 by 478, 478. This is done. Now again, effects, go back over here, and borders, visual borders. This is done. Then again I'll do a copy paste, and let's say negative class, negative class. This is also done. Now let's just arrange this all very quickly. I'm going to drag this down. Here I will keep the positive class first. Now I highly recommend you to watch this video on the speed of 1.5 at least, because this is super slow. Okay, now let me arrange this over here, and all the three positive classes I need to bring inside that. This is positive class. Okay, this is positive class. I need to put it just right inside here. Okay, now what I can do is, let me just bring it like this and like this. Okay, now what I'll do, I'll just select this all and format, align, distribute horizontal. Super, this is done. Next thing is this. I'm going to arrange this and arrange this one as well. Next, let's just select them all, format, align, distribute horizontally. Okay, now the time comes when we adjust the formatting also, right? The font size and etc. that looks little unbalanced. Okay, what is imbalanced? Call values, call out value says 20 and bold, call out value, and this category 20 and bold. Category label is also 20 and bold. Let me make it everything 20 and bold. So all of these things are going to be 20 and bold. 20 is there and bold, 20 and bold. This is okay. 20 and bold, this is okay. Now the things which we need to do is change the names. So here I'm just going to rename it. If you want, you can just skip this part. This is positive, or rather I'll pause the video to, you know, make it little. All All right, so this part is done again. Now you see this is how it is formatted. Next thing is we need to create these four graphs. This one where we are considering the ownership status by actuals. Okay, so what I have taken is this one, and into this on x-axis I need to show the ownership status. Okay, now where is that ownership status? Home ownership status. Okay, this is the one that I should be getting over there. Home ownership status by actuals. Loan status, where is loan status? This is the one. This is loan status. And now what I need to do is sum of, this is not sum of loan status, bro. I just need to change it. I think what exactly I have done over here. Let me just copy that directly. Okay, so x status is percentage. This is showing in terms of percentage, right, of grand total for count. Okay, now person home owner status and in legend loan status we have given. Okay, so in legends let me again put the loan status so that it could show a different color. Legends, it is showing, it's quite small, isn't it? Okay, let me just show it in terms of percentage. So value as percentage of grand total. Still it is too small, can't even see that. Loan status. Okay, this I need to make count. Yeah, now this is making sense. And let me just go back over here, and from here I will switch off the titles. Let me switch off the title and values. There must be the values also. Okay, what we have, I have completely switched it off. Okay, now I can switch that off also. From here I think I should have some legend header, so that is off again. Now data labels, I want to show the reflect the data labels. Let me show that. Okay, now the point comes when we need to rename this, and the naming convention which I have used is home ownership and actuals. Okay, so y-axis I need to rename. Here I'm going to say home ownership, home, let me keep that underscore ownership, done. Then on x-axis here I'm going to rename it for actuals, and formatting is columns. I'm going to change here, I must have something called columns. Data labels, general, small multiples, y-axis, layouts, bars. I was trying to look for column, well actually it is bar, not the columns. Series, which series that I want to color, 0, I need to keep it in green. Let me choose a green color from here. These all are just the formatting part, so if you are interested in skipping this, you are more than welcome to do so, and that actually makes sense, right? Now then after this, the true values, and for that I'm going to keep it red color. That's not actually red. This makes sense. Okay, this is done. Now after this, let me just put it right over here, and I'll try to keep it like this. Okay, super. Now I just need to change the border is already visible, is that so? No. Okay, this is done. Now the same thing I need to do a copy paste, and into that I'll put the predicted one. And let me see what is the space, what is the size that I can put, the dimension. I know the video is turning out to be quite big, 208 by 320, 208 by 320. Let me make it 208 by 320, 208 by 320. Super. This is done, and same should be the case for this one also, but I think that's going to be a little big. For that purpose, what I would require to do is take this all little above way here. Okay, and let me try. You can do the adjustment as per your convenience, that's absolutely okay, but here I'm just trying to keep everything in the same alignment. That's the case, that's why I just have to put this. Okay, now for this one also, what was the dimension for this? Let's just come back over here. 208 320, 208 320, 208 and 320. Looks 208. This has to be 208, 208 320. Good, pretty well. I can bring it a little closer. This is going to be perfect size. This item also needs to be selected a bit down. Okay, this is also done. Let me bring this also a bit down. This is done. Now the next part comes is creating this particular plot. So here you see at x-axis you have person's income, and y-axis you have actual versus predicted. Okay, let me create a line chart, and for this person income, that I'm going to put on x-axis. That should not be the sum. Is that the sum? I'm just trying to keep the same thing. That's why person income. Okay, that is as it is. No calculation performed on top of that. On y-axis, I need to put two things. One is XGB prediction, and then the loan status, actual loan status. Where is the loan status? There it is. Okay, so everything it is showing in sum, and I have actually kept that as sum only. Okay, let me see that. Yeah, you see this is in the pop-up, it is showing sum, right? So that's how it is. Okay, now let me just make it of the same size. I know I'm focusing a lot on formatting part, but if you want, you can do it at your convenience level, right? If you don't want to pay much attention on this, you are more than welcome to do so. But yeah, this is how it is. Now let me just rename this here. This is prediction, predicted, and this is actual. Okay, this is done. Predicted versus actual. Here what I have done, predicted versus actual. Now the time comes when I change the color. Next one is visual border, yes, and over here, not here, here, x-axis, y-axis, is there something for line color? Here predicted has to be, I'm keeping predicted in red color. Predicted I will keep in red color, and actual I'm going to keep that in green color. Super. And then comes this part, I need to reflect it right away here. Legends, I must be having something called top right. So you'll get the idea how to do the formatting also. That's why I'm taking it in a bit detail. Don't worry about it. And like I'm saying, if you want, you can of course increase the speed, or maybe you can just skip this part, right? It's absolutely on you. and here I'm going to remove the title. Super. I think we are almost done, guys. Now I'll just bring this down. Oops, something wrong has happened. Something has gone wrong. I think I have copied another chart. Okay, this I need to select, copy paste, bring this down a bit small, and over here I just need to make this adjustment. This is also done, and over here I'll just change the x-axis. Rest everything I'm going to keep same. Instead of person income, what I will put is person income. This says person income, home ownership, loan percent income. You see, this is what I need to use in x-axis. Excellent. Now I will just rename it debt to income. Debt to income. Okay, this is also done. Now the time comes when we need to put the final text box. Classification, model monitoring. Okay, now let's just put that also. Classification, model monitoring. Please ignore this dog's noise, otherwise I would require to pause the video. Okay, let me see. Classification model done. Center, and let me make it a little bigger. Okay, not that, bro. Let me make it a little bigger, 50 somewhere, or 60. Yeah, this looks pretty fine. This is pretty well. Yep. And let me make this like this. Now little extra, I don't want to have this scroll bar, so that's why. Now over here in the effects, again I need to make it visual borders like this. Super, we are done almost. Now we just need to apply the theme so that it could look better. I'll keep it little higher. Okay, we are done. Next part is let's just go to the view tab, and from here I'm going to apply the theme, this one. Boom. Now one more thing which I will do very quickly over here, I need to just change the border for each of the graph to white, or maybe for all of the objects. Let me just see if I can do it like this. No, I can do it like this. So I'll require to select this one by one. I'll quickly show you how you can do that. Okay, now go in general effects, and in the visual borders just come back over here, and from here you can take white color. See, this is what I'm going to do for all of the graphs, for all of the objects rather, I should say. Okay, let me select this. This is selected. From here, general effect, border, I'm going to make it white. So what I'm going to do is I'm going to pause the video while I'm making. All right, I'm almost done. This one, this is the last one, effect, visual border, and from here this. Excellent. So we are done with this dash. Okay, I just missed to do it for this one also. So let me do this, effects, and then visual border over here. Let me just, okay, done. We are done with this particular one also, right? So what you see is for XGB model, positive for positive class. Okay, so this should be ideally named as precision, not positive. Okay, so it should be precision. Okay, so this is 96% is the precision for positive class, and for negative class how much it is. For negative plus, it is 91%. So it looks pretty good, right? So this is how you can also develop your model monitoring dashboard. And so like you see, for logistic regression I had already created, and for XGP I created it over here. Now for you, the task is to create the similar dashboard, or maybe even the advanced one. If you want to create, if you want to go something differently and you want to do something exciting into it, of course you can do it, right? It's not rocket science, and you can of course do that very easily. So try doing that for random forest. We already have that prediction available. If you want, you can just copy this and replicate this. If you want, you can create entirely the different one, okay? And that's going to be helping you a lot. Let me know into the comment section what was your experience. Now that we are done with developing this kind of model monitoring dashboard, in the previous video we developed this for XGB model. Now we will move forward, and what we will do is we are going to be automating all the pre-processing work which we had done in the beginning in this development, right? So all those kind of pre-processing which we are going to automate in a way so that next time that can be used as library or module, right? So you would simply require to import that and then perform the just apply the input data, and it will do all the processing into it, okay? And after that, what we will do is all the three models which we trained into this particular tutorial, I'm going to save that in a way so that you can share that with your friends, colleagues, everyone, or whomsoever you want to share it, okay? And then after that, once you share that with your colleagues or folks, whoever you want to, they all that they would require to do is just load that model and supply the input data. That will automatically do its work, and that will give you the prediction. So yeah, but it is important that before supplying the data should be in pretty much well format, otherwise it will not give the proper result whatever is expected, okay? Now that is also done, and automated modules will be used. The clean pre-processing process which we talked, that we will be automating that. After automating that, we will again see how to import that and reuse that, okay? And then we will also see how to reuse the saved models. All right, so without any further delay, let's just start with it, okay? So to start it, what I'm going to do is I'll just open a new Jupyter notebook page, right? And after that, it's just going to be copy paste, honestly, okay? So let me just come back over here. This is our main code, and out of which we need to just do the copy paste work, okay? So first of all the libraries which are needed, that I'm going to import over here, okay? Now this is done. Next thing, let me just go slow so that I don't miss any of the part. I'm trying to look for all the libraries which have been imported so far into this entire processing work. First part which we had at the very beginning, that we had already copied pasted. Now this is also done. Next, what's next? This is done. This we will copy during the automation. These are the major chunk which we need to copy paste, okay? What else that we got? Anything else? Anything else? Is there anything else? Let me just have a look. Well, I don't think that there is anything else which is left to do the import, okay? So we are pretty much done with putting all the library which are needed, okay? Now the next thing which comes is automating all the pre-processing work. So for that, I'm going to create a function. Let's call it def, and I'm going to say model pre-processing, okay? And into this. All right, let it first complete its execution. That is done. Now we will just go at the top again over here, right over here, and let me just see. We have our data frame over here imported, and then it comes over here where this is the data which is being supplied. This is the part which we require over here. So this is just to, you know, filter out the data basis on age to remove the outliers in which we had in age. Now this part, now comes this part, age removed, CR age removed. This is done. Next, next, next. This is not needed. This is also not needed. This is also not needed, but let me just do this, otherwise I would require to do more work. So let me just copy paste this and this as well. I just want to avoid any sort of confusion, that's why I'm taking everything, even if it's a normal copy. I mean, if that is important, then only. So here I'm just putting this, copied pasted. No, this line is not needed for pre-processing, so I'll just remove that part. Done. This is also coming from here, and then next part is this. This is done. Next part is over here. Let me just copy this and put right over here. All right. This is also done. Next comes over here from standard scaler. It's something which we are going to pay. Putting over here, standard scaler is done. Then after that, this is just nothing but just taking the list of columns, so that is not needed. And over here I will just put this one, then this is not needed. Then this part, this is also done. After this is group by thing, not required, and this is done. Then comes this part. Okay, that is also done. Then comes, I think this is something I had already imported smart. If not, then let me import it right over here. I don't need to do that at the bottom side. Okay, and this instance creation is something which I will consider in the automation part only. And then this is split. This is it. We are done with this. So this will particularly return us the balanced features and target. So if we require this anywhere, we can use that, though we don't require to balance it again, right? We don't really require to balance it, but just I'm putting it just in case if you want to utilize that in some other way, you would be able to do that. Now I'll do a little bit of commenting part over here, and let me just say outliers treatment, outliers treatment. Then after this is done, this is also done. Then here the data is dumped. After this missing value treatment, let me just say missing values treatment, missing values treatment. This is also done. This is copied, data is copied, credit data category treated. This is also done. Then after that, what else comes in? This part is done. And person home ownership, this is okay. This is categorical variables treatment. Okay, categorical variables treatment done. This is done, and this is also done. Done. And after this, here comes the scaling part. Though you don't even require to do the scaling, not necessarily, but in your input data, even if you don't do the scaling, it should be fine. Okay, it should be fine, I guess. Okay, but let me just do this scaling the data, and scaling and combining. Scaling, after scaling, all the things are being combined over here, and over here this comes as This will be let me just see what it is. This will be just features and targets creation, features and target creation, and then over here comes smooth balancing. That is also done. Super. All the things are done. Now you remember, you know what, so for this purpose what we are doing the scaling on is, that's something I'm just trying to keep the format same. So otherwise if you want, what you can do is, even if you don't do the scaling, just convert your data into, you know, you can just convert the you can just do the character values treatment, and after that you can try to utilize the data. After that you can directly try to utilize the data in your model. Okay, so data to scale, over here we have this data to scale. I will also try to return this into it, and at the end we need to return the output. Return the final data sets. Okay, and over here what I'm going to say is return this data, which is data to scale, the data which we have prepared, which we already have ready available over here for the scaling purpose. That's something which we will be utilizing, data to scale. Then after that, whatever features that goes into it, then after that whatever targets that we have and goes into it, and then this too. All right, so all is done, this all are done. Okay, let me just see, it is created. Now I will just do the testing of this, whether this is fine or not, and once that is tested I will save this and then I will show you how to utilize that. Okay, so let me very quickly do the testing of this data, and for that purpose what I'm going to do is I'm just going to take this and let me import this. Here I'm going to say df, and here also I need to make supply the data frame, put the condition to supply data frame. And now out of this, as soon as the data set is supplied basis on this condition, that will be stored into it, and then rest of the things will go as it is. Right, over here also I need to put the data frame. Okay, that is done. Next comes this, and then after this what we're gonna get is model. Ooh, yes, model pre-processing. Okay, and inside that let me put df, and after this all these data sets, if you're looking to create all these data sets, that you need to put over here. I mean, naming convention can be different, right? Naming convention, whatever you want, you can just put. And let's just give it some time. Okay, the processing is done, and let's just check data to scale dot head. Good, so we got this data, right? Data to scale, this is what we got. And then let's just see features, this is the scaled data. Then balanced features, very good, excellent. Then target, this is also done, and then this is over here. Okay, done, super. After this is done, I'm going to remove this as well, and let's just save this. Over here I'm going to say PD model pre-processing PD model. All right, this is done. Rename and save this. Super, that is saved, and I would require to download it as .py file from here. Once this is downloaded, I need to put it in the working directory where all of my Jupyter notebooks are saved. Now, if you want to know where your working directory is, so for that purpose, you can just write one small command, and that is import os, and after that os.get current working directory, get cwd, right? So this is the location which I need to look for. So here I have the downloaded the automation which I just did, that is available right over here. And after that, just come back right here, and from here I'm just going to remove this. It just does not require that. Okay, so this is over here, this is where I need to put this particular program. So I'll just copy this and paste it right over here. All right, this is done. Here we got this. Yeah, pre-processing PD model. This is what we needed to do. Now after this, the next thing which I need to do is I will save the models, though that is not needed to further utilize that particular module, but I'm just trying to keep it in a sequence. Okay, so let's just see where we have first created our, where have we created our first model. Done, this is done, and this is also done. Done, 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 done. This is done, done. Where we have here comes our first model. Here model training was done, and just after this what I'll do is I'll import pickle. So if you don't have this already installed in your machine, you would require to install it. If you struggle to install it, do let me know. I'll create a, I'll give you the syntax how to install this. Okay, nothing much, just do pip install. You can simply do Google, you'll find it. Okay, and after this and in the previous video also I have captured it how to install the pickle, so I'll try to put that in somewhere. Okay, now over here you need to say with open, and here I'm going to say logistic PD model, PD model, logistic PD model dot pkl, and over here I'm going to say write binary as file, and over here what I need to do is I need to say pickle dot dump, and into this I'm going to write the name of my model, which is locate, and after that here I need to put file. Oops, dump. Module pickle has no attribute dump. It should be dump, not dump. How can I do that? Okay, so this is done. Now what I can do is this particular model is done. Ideally it should be available into its working directory. So let me refresh it over here. Now you see over here logistic PD model, this is done. Next one is random forest. Now where the fitting was done, right over here, and after that I'm going to just pick this, copy paste this just to keep it quick, right? Random forest PD model, this is also done, and over here I need to put RF. This is done. Let's just see, I didn't imported the pickle because you are aware library is something which we need to import only once. So this is also done. Next is XGB model. So here the training was done. Just after this I'm going to put that XGB model right over here. Here I'm going to say XGB PD model. All right, this is done. Let's just save this as well. Super. Now here we are done with automating the pre-processing work, and here we are done with saving the model. Now let's just go back in this folder and see if all of those are available here or not. Super excellent. Logistic model is available right over here, random forest is here, and XGP model is right over here. All the three things are available. Now the time comes when we need to use these all things, right? So what I'm going to do is I'm going to import open a new workbook file over here, and I don't need to do all this, right? So here I'm simply going to say import, and the automation which I had done, what was the name of that? If you remember, this is the one, right? This is the one I need to do, right? As pre-pro, that's what the name I'm going to give it. And like you can see here, I'm just importing it the way we do the pandas import, right? The way we do the pandas import, that the same way we are doing this. Now once this is done, everything that you had available, all these prerequisites, library, and everything is imported into it. Now you don't trust my words, just check it out. Dir, and here you say pre-pro. All that you need to do is just say pre-pro, and after that you're going to get the list. Now you see all the libraries that are available over here: numpy, pd, pandas, matplotlib, seaborn, trend test split, everything is available into it. And the function which we had created, model pre-processing, this one, model pre-processing, is also created over here. Where do you see model pre-processing? This is the one that is also done. Super. Now the next thing which we need to do is just import our data and do the pre-processing. Okay, so for that I'm going to create a data frame part, and for that what I'll do is I'll directly pick that from here. This one, just come back over here and let's just put right over here df, or you can say anything, right? Whatever the name you want to give, you just give it to it. Oops. Wow. Okay, so now from this library, if you want to use pandas, so what you would require to say is prepro.pd.read csv, right? That is done. Now df, you just check it out. Here you go. Here you have the data imported. Now the time comes when we require to use that model again. So if I have forgotten that, what is that name? Model pre-processing. Model pre-processing. No. Model pre-process. What was that exactly the name? Pre-processing. I'm just missing the name of that. Do you guys remember it? Okay, let me just check it out. dir pre-pro, and inside this model pre-processing, this was the function name, right? And inside that I'm going to put my data frame, and that I need to store how many features that we had created, how many data frames that we had created, all these data frames. So I'm simply just going to how many are there? This must be 5. 1 2 3 4 5. Okay, so let's just put this name, scalable data, just ignore the spelling error if there is any. Scalable data, then here I'm going to say features, and here I'm or you can also say inputs, status, actuals, rather we can say actuals, and then here I'm going to say balanced input and balanced actual. This is done. Looks like model pre-processing is not defined. What was the name? Model pre-processing is defined, in fact. Why it is saying that it is not defined? There seemed to be some issue. I just need to look into this. It must be working. I get it. The challenge is this is part of this file. So rather I should say prepro dot model preprocessing. Now this will work. Done. Now let's just check scalable data dot head. Done. This is looking perfect, isn't it? Yeah, this is looking perfect. Now let's just check the balanced inputs, rather I can check dot head. Headers must be same. In the input we have these columns also created, which we don't have available over here, right? So because this was for the scaling purpose, into this character variable statement we had not done and concatenated. So this is the perfect data to use in our model though. So what is it if you don't want to use the scaled data in your see, this has the scaling done. You don't necessarily require to do the scaling before using the data. or maybe if you want, scaling is something, if you want, you can do. And again, the problem is, in the previous video you might have seen that I created the tree models like random forest model and XGB models, and into that I utilized the scaled data, which does not make much sense. In tree based models, scaled data does not require, right? So I used that over there for the learning purpose, and you saw that we tried to calculate the feature importance, etc., everything over there, right? So for that purpose it worked well. But in practical life, if you are building the tree based models, you don't necessarily need to scale your data. What you can do is you can just do the pre-processing and you can use that. Why? Because tree based models works in stage label classification. It picks one attribute, then does the classification, then another, and then does the classification. If you'd like to understand that in detail, do let me know, I'll explain that. Okay, so over here, let's come back to the point over here. And now that we have our data available, this is the data which we will be using in our models to test I mean, whatever models that we have created, we're just going to utilize that, how to use that. Okay, that's what we are going to see. Now this is the data which I will be using. Other than this, what you can do is, if you want to use this absolutely raw data, I mean, when I say raw, means treatment of missing values and the outlier, after that you just concatenate these parameters into it, and then you can utilize that, because it is important to supply all those features which we had supplied at the time of training our model. Okay, now the time comes when we should try to utilize our models into it. So again, I'm going to say import pickle. Now let's say that somebody has shared these three models with you, right? These three models has been shared by somebody with you. Now you see how you would utilize this. Okay, so for that we can say with open, and out of this, the file, first, this is the one I'm going to use. Let's just put this, and here let's just say rb as file, and over here I'm going to say pickle dot load, and over here let's say file. Super. Now I'm going to import all the three. Logistic is done, then random forest, is done. Then the next one is XGB model. I'm importing all the three, and then we can try to check it out. Okay, let me just copy paste it over here and come back over here, and let's just do this over here, right? Let's just put it. Super, this is done. Now the next thing is utilizing the model. Logistic, what is it that I had created? Logistic, not logistic PD model, and inside this, okay, there is one thing which I should do, and that is this. I just missed this part, sorry for that. And this one, okay, this is also done, this is also done. Done. And this comes now. If you would try to check it out, you would get logistic PD model, and inside this, let's just supply the input, but here we need to use predict, and logistic prediction. Here we got the logistic prediction, and let's just run that. Oh, it just gave the error. What is the error? Here it says input array module, this it is a single sample. There seemed to be some issue over here. Let me just investigate it. What's the issue? Inputs. Let me just try to use inputs right over here. Okay, that is done. And let's just try to see the output which we got. Ooh, we got it. Now let's just try to print the classification report. Classification. Okay, so from sklearn dot metrics import classification model, classification report, and from here I can say classification report, and inside this let's just put the actuals which we had created, and then logistic prediction. And let me put it into the print statement. All right, excellent. So here we got the things which we were looking for. Now you see all these three models are loaded into it. You can go ahead and use these three models, right? And if you want, you can just share this with your friends also. These three models, you can share it with your friends and they can also try to utilize that in the same way. Here I just showed you how to utilize this logistic model. Now the way I utilize it in these three lines, same way you try to utilize these two models also, and let me know what is the performance that you got, what was your experience, right? So I think it was very much clear to you. Just to summarize it very well, what we did is, first we tried to automate the pre-processing work. Now remember, every time when you are getting the data, you would not necessarily require to do the missing value treatment. Sometime you may get missing, sometime you may not get, and sometime in some of the attributes you will get, and sometime in other attributes you will get. Here the missing value treatment which I have done, that was done in loan interest rate. There could be high possibility that the same set of data, if I'm getting next time, this particular attribute would this particular feature would not have any missing, but the other feature which would have other missing value. So in this automation, that particular scope is still there, and which I highly recommend you to put your mind and try to automate that part also. What you can do is, you can put the condition, if any attribute, any feature has missing value, then only apply this particular technique on that, otherwise just skip that. Here I had hard coded it just to keep it simple, but I highly encourage you to do that, to do this automation in a very dynamic way, right? Or if you want me to do this, just let me know into the comment section. I will be more than happy to do it for you and show you how you can do that, but it requires to be dynamic. Here it is very very static, very very hard coded thing, which is not good in the practical life. But here only purpose was to show you how a model is developed in real life or on your real job. I wanted to give you a end-to-end view how you can approach the model development, so that it could give you the enough confidence, and you can go ahead and start the development end to end, right? And even if you are going into the interview, you would have full confidence to explain how you can approach a model development from end to end. What all are the major steps that you would require to take? All right, so this is the purpose which I wanted to solve into this tutorial, or maybe in this workshop session rather, you can say, which I think I have done. Rather, you further you can give your feedback, of course, into the comment section, which will help us to improvise the quality of the video. Now, very very quickly, let's just have a very quick view and summarize what all that we have learned over here. There are a variety of things which we have covered. First one, exploratory data analysis and feature engineering is something which we have seen, under which we covered statistical analysis of the data, outlier treatment, we did missing value treatment, we did the categorical features treatment also using one hot encoding. Then we saw how to do the scaling and balancing of the data. For that, what we did is, we did scaling, data scaling using standard scaler. Then we did data balancing using smart. After that, of course, we did the model development, where we did model training and testing with logistic regression, random forest, XGBoost. Further, we saw how to calculate the classification report, under which we can calculate precision, recall, F1 score, accuracy, etc. Then we also extracted the feature importance calculated by each of these three models, which is logistic regression, random forest, and XGBoost. In logistic regression, we extracted the coef, which served as the feature importance. Coef means coefficient. Random forest and XGBoost particularly provides you the functionality to extract the feature importance, which we did. You saw that, right? Then we did the visualization for model monitoring process. You saw how we created a visualization in Power BI, which can be used, which can be demonstrated the process of model monitoring, for the process of model monitoring. Then further, we saw a kind of deployment of the model, where we covered how we can automate the entire pre-processing work, though that was having many of the hard coded things which I encourage you to go ahead and do the automation. And then we also saw how to save and reuse the model, share that model with the other colleagues, etc., and reuse that for the prediction. So it end to end it covers quite a lot of things into this video, and that's definitely going to give you a whole picture of end-to-end development. Hope you liked it, you enjoyed it. Let me know your feedback, your suggestions into the comment section so that we could implement those things in the upcoming videos. Thank you very much once again. Wish you very good luck.